Energy Markets and Finance at NYSERDA, and he is leading up our effort to develop this roadmap. So take it away, Greg. Thanks.
Thanks, Zach. And welcome, everybody. Appreciate the robust turnout today in all of our locations and on the web. So again, thanks for taking the time to help us with this roadmap. We will spend most of this time listening to you, not downloading our information out to you guys, but I'll do a quick update on the Climate Act and the roadmap status for anybody who hasn't heard this yet. And for people who this is like the 5th time, I apologize. But so today's session is really about the nexus between the building and the grid. It's really hard to imagine that we get to the answers in this roadmap and don't come up with the idea that kind of a primary pathway is decarbonizing the grid and electrifying buildings. But when we do that, we need to think about how we're going to do that, and we need to do it smartly. We need to do it in a way that helps us get to a carbon neutral building stock in the most cost-effective manner. And when I think about that, I think about the woeful capacity utilization rate of the grid today, which is about 55%, meaning look at all of the grid assets over the span of a year, and on average, they're being used 55% of the time. And that is way short of what other industrialized sectors accomplish with their equipment. So it would seem to me that one way to do this in the least cost or the most cost-effective manner would be to absorb that unused capacity, which means being able to shift loads around either quickly with control mechanisms or sort of a slower way to shape load through thermal storage or phase change material or any other methods like that. So that's what we're really looking at today. This morning it's about policy. How can we use rate design, other utility regulatory policy, look to encourage electrification, but then to encourage to do it smartly, like I was just talking about. And then this afternoon we'll have a second session on more about the technical feasibility and the equipment and the state of the market to do that. So for anybody who doesn't remember, we did pass probably the most ambitious climate legislation of a major economy this summer called the Climate Leadership and Community Protection Act. It tells us that it tells New York State that it's going to be carbon neutral as an economy by the middle of the century. It sets a specific target of 85% reduction in greenhouse gases by 2050 from 1990 levels. A couple of important points there are then codified a bunch of milestones along the way, which include 70% renewable energy by 2030 and 100% carbon-free electricity or clean electricity by 2040. The change in those words is intentional because the 100% clean could include nuclear. There are also targets in here for offshore wind, tripling our ambition by 2035. One of the main ways that we will be developing enough renewable energy to meet these goals. It codifies the new efficiency New York efficiency target of 185 trillion BTUs by 2025. And the interesting thing about that is it will get us about a third of the way toward our 2030 goal, which is to get a 40% reduction in greenhouse gas. And if people think about the math, a third of the way toward 2030 goal means we've got a great deal left to do even after we achieve the ambitious new efficiency in New York. So let's keep going. Same time, New York City passed the Climate Mobilization Act, which is their version of the climate legislation, and in particular, most people around the room here know that it includes Local Law 97, which sets a specific cap on greenhouse gas emissions in buildings greater than 25,000 square feet. And that cap will be starting, the first number is in first compliance period is 2024, and then that cap will be coming down over the years, 2030, and then every 5 years after that. So all of these, both of these pieces of legislation, if we're going to meet those greenhouse gas targets, mean we have to have a carbon neutral building stock by the middle of the century, and that's all buildings in New York State, and that's what we're working on. There are a bunch of elements of this roadmap. One is we have some research out being done by E3 and RMI and RF and New Buildings Institute. That should be coming back in the next couple of months. We have had lots of stakeholder sessions, this one being, I think, the fifth of a series. Count each morning and night as one. Then we have a few left to do. We'll get to those a little bit later on. One other thing to understand is that this is a living document, so this is the first iteration that we're putting out here, and we expect that we'll be putting out amendments or new versions of it every, I don't know, 4 or 5 years as the markets change, technology changes, policy changes. So the roadmap needs to cover, like I said, all buildings, and that means it's not just new construction, but it's existing buildings as well, which is probably the harder to get to. And on existing buildings, you got to be able to figure out how to take a building at one time and convert it to carbon neutrality, because a lot of work's already happening in that building, so you want to do it all at once. But then there are also buildings that follow a longer term phased capital plan. We need to understand how to sequence things so that over the span of a decade, you could wind up with a carbon neutral building because you've done all of the elements over a period of time. We are focusing on 4 sectors deeply in this iteration. They're single family residential, multifamily, office, and higher education. And we are on the multifamily and office paying more attention to low and mid-rise buildings in this iteration, and we'll talk about the skyscrapers, but they'll be mostly in another iteration to come. So lots of pieces of the roadmap. We've been working on our table of contents and moving things around and moving the subchapters around. Here are your chapters, essentially. Building electrification being right there in the middle, and then policy and regulatory options is kind of that juncture that we're going to be talking about today. So just on the schedule, we are frighteningly close to the end of our phase 1 research and writing task. We're looking to have that done by the end of March, and we have different people writing different chapters. Drafts are coming in, and we'll pull all those together and hopefully have a roadmap to publish the first draft to the public sometime at the beginning of the second quarter of 2020. And then there will be a period for a broader public comment on the draft. And we'll pull that back in and reissue and edit, compile. And the idea is we get to a point where we're publishing the roadmap by the end of 2020. So I'm going to stop here and turn it over to Scott Johnstone, who is the new energy market lead for VHB, which is an engineering and science services company.
folks may know Scott from his past work as, for example, the head of the Vermont Energy Investment Corporation. But he's really good at getting people to speak. So everybody jump in. We really want to hear from you, and also no idea is too crazy to bring up here. We want to hear everything. So take it away, Scott.
Great, thank you. One thing I would say, a couple things for folks here in the city. We do have people on webinar and in Albany, and so it's going to be easier if most of you would try to fill in as many of these seats at the table as you can. We'll still hear from the rest of you out there. I'll just probably have to repeat what you say for folks, so it'll just be quicker if we fill in the seats. Second, with the mics, while they have great coverage for us to hear in this room, at least past experience in other sessions, is the mic has to be really pretty close to you for the people on the webinar and in Albany to hear you. So if we can do that, that'll be helpful. It's great to be here again. We're going to, if you go to the next slide, start with just a couple definitions, get us moving here. The first is grid interactive efficient building, GEBS by another name, and at least we're using the U.S. Department of Energy Building Technologies Office definition here for today and for this effort, which is an energy efficient building with smart technologies characterized by active use of demand energy resources and intelligent controls to optimize building energy use for a wide range of issues. You can look at that as we go forward. And then grid modernization is modern grid has to improve reliability for everyday ops, enhance security, have additional affordability to maintain economic prosperity, have superior flexibility for the wide-ranging issues that we deal with, and then be able to adapt to a range of energy futures as we move forward. So I'm not reading word for word here, trying to characterize, but so we can keep moving. So just a couple of definitions to have us be thinking about today as we move forward. They're going to be important pieces that we're talking about. As noted, we're going to start with a series of presentations. I'm not going to read these word for word for you, but Kara Carmichael is a principal at Rocky Mountain Institute. My quick read of this is that she's a grid interactive zero energy building expert, and so I presume that's what she'll probably talk to us about. Again, you can look at these at your leisure. The next is Rebecca Kraft, who is an electrification expert with lots of rate design experience and has worked inside utilities as well, which is good, inside NL. She's with Sidewalk Labs, an advisor to them. Dan Egan is Senior Vice President of Sustainability and Utilities for Veredo. He comes at this with a real estate perspective, over 30 million square feet under management. So that's a really important perspective when we're talking about GEBS for sure. And then lastly is Ed Thomas. He's the Executive Director of Peak Load Management Alliance, which pretty much says what he's going to talk about. So I'm going to not belabor that at all and get us right into these speedy presentations, and I think therefore, Kara, you're up.
Oops. Excellent. Thanks, Scott. Can you guys hear me okay?
Yes.
Okay. Well, thank you for including me in the conversation today. I'm looking forward to the discussion. So next slide, please. Great, so there are three things that I'd like to cover briefly with you guys today. Grid interactive efficient building, GEB, the definition and synergies with electrification efforts, GEB policy recommendations that are coming out of a GSA advisory committee task group that we were a part of, and then key findings on the value of GEB for GSA based on some research, some recent analysis that RMI has done. So first off, we totally agree with the DOE definition, and perhaps just to add a little bit more color to it, we see GEB as a co-optimization of 4 different building attributes. So energy efficiency, renewable energy, which we're pretty good at today, and then in addition, load flexibility and energy storage, which we're really just starting to better understand and harness at the building level. So a GEB strategy is really focused not only on energy use in terms of kilowatt hours, but also energy demand, and more specifically shaping the building's demand profile to save costs to the building owner as well as the utility. So next slide, please. So we see there are three key differentiators between our buildings today and what we need to move forward towards in the future. The first is interoperability and intelligence from building to grid. The second is this interoperability and intelligence across building level systems. And the third is load flexibility and demand-focused optimization. So in the first, we need to shift towards a two-way flow of information between buildings and the grid. In the second, we need to make sure that there's a central controls platform that can manage across building loads in a synchronized way so that we can optimize for different variables such as cost, carbon, reliability, et cetera. And then the third, we need to shift our focus from just managing energy and perhaps responding a couple of times a year to a demand response event to really having the capacity in buildings to shift and shed demand, not only in an instantaneous matter, but moving towards longer term shifting. Next slide. So GEBs carry great value today to both building owners and the grid. So for building owners, GEBs provide cost savings, and sometimes quite significantly, since demand charges can be more than half of utility costs for commercial building owners and operators. For the grid, 80% of grid peak is driven by buildings, and more than 10% of grid infrastructure costs are spent to meet that peak demand that occurs less than 1% of the time. So it's also worth noting that in New York State, there's some correlation between wholesale price and emissions, which is good, whereas in other parts of the country like California, there's a gap that many utilities are struggling to rectify through rate structures. Next slide. Okay, so first off, a grid interactive building does not necessarily mean it's an all-electric building. However, that combination of an all-electric grid interactive building provides the lowest cost scenario to both building owners and the grid. So this is just a conceptual diagram that looks at kind of a conceptual 30-year costs in three different scenarios to both building owner and then to grid stakeholders. So under a business as usual scenario to the building owner, there's CapEx and OpEx to maintain a building. With an electric-only conversion, there's going to be more CapEx than a business as usual scenario, and there's also going to be potentially higher OpEx. So under the all-electric plus grid interactive building scenario, there will be a higher upfront cost to implement those, an all-electric GEB solution, but that's going to provide much lower operating expenses, even as rates shift around or become more time of use based, since buildings will have the ability to shift demand to benefit owners under different rate scenarios. For the grid costs, the bar graphs on the right, similarly, there's a potentially significant CapEx cost to accommodate increased generation and transmission and distribution associated with increasing electric demand. And it'll also likely imply a shift in peak grid demand from late summer afternoon to winter morning, or an additional peak in the system. However, a grid interactive building could help avoid some of those major generation and T&D expansion and improvements, since it can hold demand to similar levels as we see today, while also enabling the grid to leverage more renewables. So an all-electric grid interactive building is able to shift the building's loads to when the sun is shining and the wind is blowing to maximize the use of low-cost renewables on the grid. So I haven't seen actual kind of numbers put to this combination of technologies, but I think it could be a worthwhile analysis. Okay, next slide, please. So the second topic I just wanted to share with the group was some work that was done by a task group under the General Services Administration Green Building Advisory Committee group. And so about a year ago now, we published 13 policy recommendations around grid interactive efficient buildings, and I'm just thinking it could be a good resource for this group. So next slide. So there were three main categories for these recommendations, and I'm just pulling kind of the highest priority recommendations from that. And it's worth noting that New York has a head start here since there's already somewhat of a channel for distributed energy resources, you know, that market created through the REV process. So of these high priority policy recommendations, I think the three that are most relevant are A1, B1, and C1. So A1 provides language for goal targets that are not only energy use intensity focused, but also demand focused. And since this has been done, several key efforts in the industry are actually leading in some metric creation around what a demand target could look like, including Lawrence Berkeley National Lab's Flex Lab work, as well as New Buildings Institute's Grid Optimal initiative. And I think New York already has an edge here as well with Local Law 97. So B2 encourages all new construction projects to have some level of load flexibility incorporated, and C1 requires more transparency around grid demand and emissions profiles, as well as grid needs. So next slide. The last data point that I wanted to share with you is RMI's key findings of a recent analysis on the value potential for GEB in the GSA portfolio. So really, what is GEB worth to building owners today? And this is the first study to look at it from that perspective. And what we found that there are three buckets of value to GSA and to building owners in general: the direct value, the indirect value, and then the societal value. So in the direct value, if GSA were to implement GEB across their entire 10,000 building portfolio, it would result in $50 million annual cost savings. And at the project level, our analysis showed a 30% on average savings with sub 4-year payback periods. It was a pretty powerful finding. Excuse me. The indirect value that GEB provide are increased leadership, better value on performance contracts, and improved control of buildings. And at the grid level, we found this could reduce grid T&D and generation by up to $70 million a year, with a demand reduction potential that GEB can provide that's twice as effective as the current demand response participation is providing. And all these findings are publicly available. So I guess to close, I think grid interactive efficient buildings can lower capital needs for both the transition to electrification and a low carbon electricity supply. GEB's lower cost for building owners in New York, even under today's rate structures. And I think in terms of those rate structures, time variable rates will help drive demand flexibility, which will help lower grid costs and emissions. So thank you.
Thank you, Kara. That was great. And for everybody that wants to hop in, we'll do that. We're going to go through the lightning rounds, and then this is all the fodder to get us talking. So, Rebecca, you're up now. Okay.
Sounds good. You know, boy, I lived at a utility for 4 years ago, 4 years ago, and you know, this discussion was going on then, and it's going on now, and it doesn't seem like it's progressed much. I think with the climate crisis really coming to finally to a fore in people's minds, maybe it will. I'm going to talk about electrification really in the context of a project that Sidewalk Lab is trying to do in Toronto, which will not be a net zero climate positive. It will also be affordable. So we've been thinking about how do you make a fully electrified grid affordable, which is a big deal when you think about electrification and its potential to double demand. So we think there are three main components. Greening energy sources, obviously, is a big one, but this means all non-fossil resources, something Greg mentioned earlier. It's, you know, solar, it's battery storage, it's wind, but it's also using waste heat recovery, anaerobic digestion, thermal resources, heat pumps. It's thinking about the non-fossil side of power in a holistic way, and also thinking about it with electricity, thinking about how you manage the two together. The second piece is reducing demand. Super efficient buildings are one. Looking in the Toronto proposal we submitted, we're looking at passive house inspired tall timber buildings, and that alone makes a huge reduction in demand and energy use. It also means a little less infrastructure, hopefully, in the long run, something that Carol mentioned. We also think it's really important to have dynamic pricing. I'll get to this in a minute. And the third piece is to optimize energy use, and that has a couple of components. First, it's really, really important, particularly thinking commercial buildings, to weed out the electricity use that no one cares about. And it actually degrades comfort, overheating in the winter, overcooling in the summer, overcooling in the winter. But it's important to do these three things together. On the residential side, we think that probably one of the most important things one can do, true on the commercial side as well, is have real-time dynamic rates. And they really don't exist now, and there's some of these structures out there. And actually, I want to digress a minute. I'm not a rate expert. I play one on TV. Bill might know that, but I certainly have a lot of ideas about rates. And finally got to a place where people were willing to listen. And I'm not sure that's good or bad, but we'll find out. Time of use rates that exist, even the real-time rates that exist, don't really include all of the charges that are embodied in a rate. And we think that it's important to have a real-time rate, an hourly rate, a sub-hourly rate that includes all charges. So you actually have a really meaningful difference between a peak price and an off-peak price. And clearly, when carbon is concerned, that makes a lot more difference in a place where carbon and price are highly correlated. In Canada, where we're looking at this project, that is the case. In New York, it's somewhat the case. It's not as true other places, but because we don't really have a good sense when carbon is on the grid at a micro level at any given time, it's really hard to know if it's valuable in all places. But we also think that people can't be expected to pay attention to energy all the time. They don't want to get people to reduce small energy install increments is difficult, as we all know. Even to do things that make economic sense is difficult. So we think that demand management has to happen automatically and continuously. And information provided and options provided, but you have to make it simple. I think this is true on the commercial space as well. And we also think that you have to incorporate renewables and storage early and make that simple and make it available. In Toronto, we're looking at a way to have people subscribe to shares of on-site solar and storage on a fixed cost basis so they can mitigate price increases, but also so they can partake more in a green outlook, which is hard to do in multifamily buildings, easier to do in other places. Finally, we think that bills have to be transparent, they have to be understandable, and they have to be provided, or information on the bill has to be provided on a regular basis, like daily or hourly, so you know where you are and you can plan accordingly. So we're going to test this. We actually got an opportunity to test these ideas, which is a beginning to what we're trying to do in Toronto. We're going to do this in Ontario with a smaller utility. And in that test, we're going to have a real-time rate, which we're building now, where all generation, transmission, and distribution costs will be built into the hourly rate. It's going to move every hour based on the Ontario market price, but also demand on the grid at that hour. We're going to control hopefully 80% of the demand in the home with a bunch of different technologies. And we're going to control that demand based on the residents' desired budget and comfort level. So they can tell us that early and often, and the adjustments to demand and to end use will come automatically over time. With an opportunity to opt out, but the idea is to make it seamless and easy. We're also going to model some solar and storage so we can offer theoretical shares of that to see if there is customer engagement around that, and to see how much that will actually mitigate bills and mitigate price increases. And finally, we're going to have an e-bill that will be available every hour to show where you are at that hour and to show what the cost of opting out of an energy management plan would be for that hour or for a larger amount of time. On the commercial side, similar kinds of problems. Studies show that the buildings use energy, way more energy than their code compliance model, and that energy use varies widely between buildings, even though the age and ratings may be the same. We also know that tenants drive a lot of its use, and they don't have a lot of opportunity to control temperature, hot water, lighting, flood levels. No one's looking and no one's controlling. And finally, we think that most equipment is run with a set it and leave it approach, where loads can change things. Often there are lease structures that prohibit efficient changes for optimization and efficiency, and tenants can't really get what they want when they want it. So as on the residential side, we think that one, first studying and then automating a lot of this opportunity is critical. So tenants don't have to pay attention to energy demands when that's not their business. But we think building automation has to really provide information needed in the moment to plan for the right outcomes in the next moment and beyond. And that has to shift over time and learn over time. It also has to be that the systems that do this have to be kind of open source, modular, and replicable. Otherwise, it's way, way too expensive to do this kind of thing on a one-off. Also on the commercial side, I think it's really important to come up with a different kind of building code. We know that energy benchmarking is moving in the right direction, but it's certainly not perfect, nor are the measures that are around today, EUI, kilograms of CO2 per megawatt hour. They're good, but they don't really account for occupancy, and they don't really account for dynamic carbon intensity of the grid. So we think it's really important to move toward measuring occupancy and seeing what the true impact is on energy use and demand. And we think that it's important to, at the same time, figure out how to get a grid intensity measure for as lower than their main transmission level. In New York, you can kind of find that out at the NYSERDA level. We're looking hopefully to find that out at a smaller level, like Zone J, for example, so we can actually see what's going on. And we're interested, we started to, and we're interested in doing more of this, which is adding occupancy counters to dozens of new buildings in New York to better understand the relationship between energy and occupancy. And we're exploring the grid side with the NYSERDA right now. And then let me talk about some more about what we're doing in Toronto. It has all the components I mentioned before about the rates. We have proposed there a thermal grid, partial geo-exchange, waste heat recovery, that design change. The idea is that we would control both the resources, on-site solar, on-site storage, all of demand and end use, together with the thermal grid in sync, so that we can produce an optimized outcome, both to reduce bills and to reduce demand. And when we modeled this, the demand, business as usual demand for a 3 million square foot development, about 5.5 megawatts without electrification. If you electrified everything kind of in a business as usual way, that demand goes up to over 11 megawatts. The passive buildings take that down quite a number. The thermal grid, and there's not going to be any natural gas at the development, so that drops the demand the most. And by the time we factored in energy end use, we were down at 5.3 megawatts. So that's a big change. That's a lot of embodied carbon you don't have to face by increasing the size of the grid. And it's a lot of carbon, and in Toronto, where most gas is on the grid during peak, it makes a massive difference on not just megawatt hours. And that's it. Thanks.
Rebecca, thank you. Now we're ready for Dan. Welcome, Dan.
Thank you. Good morning. So we can advance to not the second. This is an introductory slide. I think I'll dial in my first ditto comment for the sake of efficiency. I think we've gone through the overview of the regulations, so you can advance to the next slide. Thank you for having me this morning. Happy to be representing the real estate industry in this conversation, or at least in the lightning round. Have plenty to say for this afternoon when we talk about what's happening inside the building and how there's a lot of solutions there and challenges that fall within the purview of this discussion. But talking about this morning's topic, I think I will say the real estate community, there are many motivated leaders in New York City who are advancing decarbonization goals, have been prior to this law, to both of these laws, and are looking to continue doing such. But I think that where we are right now is forcing real estate companies to take pause while some of the uncertainties about these policies are determined. So this slide just sort of highlights four of the largest uncertainties as I see it, and as it pertains to the grid. The first being the future rate of carbon intensity for electricity and where that's delivered. So we've had a lot of conversations about geography and how those different regions are interactive with one another in the grid. I've personally had many conversations at a federal level talking about how New York ISO's sort of geopolitical boundary is unique in this country, in that we have the ability to control the state's energy planning and sort of within a coterminous boundary with the state itself. The ability for end users to purchase renewable energy certificates is critical at this time. I think it's been elevated in light of the Climate Mobilization Act. However, good corporate citizens have been hoping to more locally source their renewable supply and have not been able to do so according to GHG protocol. So possessing the REC is a very important priority for many real estate owners who have been pursuing decarbonization efforts prior to and through this current landscape. The carbon coefficient for natural gas used for cogeneration is very important. Many large real estate companies, in the not too distant past, spent quite a bit of money on cogeneration, which was celebrated here in New York State and partially underwritten by NYSERDA. I think there's some uncertainty going forward with how such technology will be valued as part of this electrification process. And then finally, city and state policies concerning Con Edison steam. That seems to be the unmentioned utility here in this conversation. We understand that steam is not renewable or carbon-free. However, it provides much value in terms of resilience, and larger customers who have quite a commitment from a physical infrastructure to steam need some more confident signals going forward with how to plan accordingly, particularly in the conversation of transitioning to all electric services. I think that we value electrification, and we understand that in an environment where the electric grid is truly carbon-free and sourced renewably, that to have an all-electric building solves a lot of problems. I appreciate Greg's comments in the beginning talking about existing buildings and the challenges with doing this sort of in a phased approach with gradual capital planning. I think with some data-driven solutions and certainties, the real estate community can probably move forward with a little more confidence. There's major capital decisions sort of waiting in the rafters, depending on how the details of both city and state policy are determined. So this just discusses some data solutions. I borrowed an image from one of my favorite annual publications, the Power Trends Report from New York ISO. I can't focus enough on the carbon coefficient of electricity. We know what it will be through 2025 here in the city. We don't know what it will be past that. I understood I'm sitting here in the PSB office, and this is not a city agency, but I can't stress enough to open up the communication lines between the two so that one agency understands what the other is working on. We've had a lot of conversations about where to draw the boundary around the sort of relevant zone of electrical generation. We really appreciate the notion of the Climate Mobilization Act that one must narrowly define renewable power in order to truly start to decarbonize the electricity that's generated here in New York City. However, I think we need to understand if there are opportunities beyond a very short list of transmission projects that will actually further progress towards decarbonizing electricity in New York City. You know, Vornado, I think over 80% of our assets are here in New York City. You know, our stakeholder group are New York residents and employees. It's really important to us that the the public health and environmental benefits of a cleaner grid is realized here in New York. However, you know, we have an opportunity to be an active and influential participant in that, but without knowing some greater detail or perhaps having a broader opportunity to participate, we may miss that, that sort of partnership that could happen. The kind of that combines both point one and point two. I think in addition to the CLCPA's goals, we need to understand what the metric will be in order to measure progress going forward. We've been pointed towards the eGrid carbon emissions rate for New York City Westchester's zone as defined in the Climate Mobilization Act. However, speaking with the eGrid division of the EPA, eGrid is done every 2 years. It is a look back on reported generation. The number in CMA is eGrid 2016. CMA's rulemaking will come out in 2023. The eGrid value that will be available for New York City Westchester at that time will only reflect conditions in 2020. And all we know about 2020 is the closure of Indian Point plant, which will add, we understand, which will be supplemented with more natural gas. So if we are to use the coefficient of electricity as our indicative number to motivate or deter us from electrification, we're not going to have a very good number to look at in 2023 when rulemaking is completed for CMA. We also don't understand how transmission improvements will improve the coefficient downstate. We fully understand this tale of two grids. I pulled that image, as I said, from Power Trends. So, you know, part of the solution, in addition to generation, should be these transmission improvements. How does transmission improvements widen the bottleneck between upstate and down? Does that accomplish something towards greening the grid here downstate? We don't understand that yet. And so we have a very informed group in real estate who appreciates the data and looks forward to being part of that conversation. The future carbon coefficient for gas used for cogeneration, I think, also helps us with longer-term capital planning. Needless to say, the community or industry is very trigger-shy about new cogen. However, you have a sort of fleet of DER in existing buildings that can be active participants in sort of this transition to a greener grid. We understand that electrification will put a short-term burden on the grid and that the availability of existing DER to offset that constraint should not be discounted. And then finally, Con Edison's team, you know, we're sort of rallying behind a plan of decarbonizing the electric grid. Why have we not had a conversation with Con Ed's team that could motivate them to have their own goal going forward? There are opportunities there to make steam less fossil fuel intensive. I certainly don't play an engineer on TV or in person, so leave that solution up to the more informed group, but I think we should not leave Con Edison's team out of this conversation as it serves a very valuable purpose towards this transition that we're planning. And if we could just go to the last slide, I've included some of my additional resources. New York Energy Consumers Council is an organization here that advocates for the ratepayer. We did complete a study to look at the relationship between electrification and the cost of electricity for ratepayers. I encourage everybody to take a look. The US EPA last year released a very compelling report that talks about the societal benefits of renewable energy and energy efficiency. I think it's super important to continue to assess the social impact of all of this great work that we're doing, and this is one of a study that establishes that tie. And of course, a plug for some of my favorite reports from New York ISO. Thank you.
Great, thank you very much, Dan. Ed Thomas, why don't you hop on and take over?
I will. Hey, thanks for helping, giving me an opportunity to help jumpstart this conversation. Next slide. PLMA is a nonprofit trade association, 160 members, including some folks New York-based there, Con Ed, Orange and Rockland, Central Hudson, NYPA, and Energy Hub. So we're not normally seen as a policy advocacy group, but today I'm going to speak to you as kind of that voice of load management practitioners to just reiterate a little bit of ditto here. But next slide. We like the fact that you're really taking this holistic approach, that including demand response along with energy efficiency and storage, and that just want to validate kind of that perspective. Next slide. And to kind of build on maybe what Carol and some others were alluding to, if you can continue to build this, I guess. Maybe next slide and then the next one. What we've seen is really this evolution from demand response being these one-way communication load control systems or interruptible rates, moving more towards with two-way and with integration of demand distributed energy resources to become kind of more of this evolution, and it's in various stages in various parts of the country. And it's not necessarily limited, by technology, and some of this has happened perhaps in spite of technology, but it really has been about how this has evolved around the country and what's happening. Next slide. And I think, but with that, we've seen peak load kind of go from 10 hours a year, or maybe, water air switches in the summer, or water heater switches in the winter, and moving more towards, as I think Kara alluded to, is this idea of flexibility in load management. So we're now, building on this with the potential for grid interactive buildings to be not just 10 hours a year, but maybe 10 minutes a day to be able to adjust load and truly shape load in ways that we just couldn't before, thanks to technology. Next slide. So, with all of that, the key points really want to leave, the key takeaways, from our practitioner perspective is in your policy considerations and making that actionable is acknowledging that there's this integrated approach that's happening around the country that you need to continue to encourage and get out of our silos of excellence around some of these things and more toward that integrated approach, and encouraging flexibility and load management strategies that are going to, in some cases, clip the peak, and in other cases, perhaps fill the valley, making it, in some cases, to increase energy usage by encouraging that kind of flexible load management overall for the benefit of the grid and for the overall benefit of the customers and decarbonizing for the environment. The third point there is really about, it's not just about getting the prices right. It's not just about waiting for the right technology. I think we've also seen some behavioral approaches around the country that really, it's both the pricing and the behavioral, as well as these embedded appliance controls, but also the systems that Rebecca talked about, and that approach of being able to take the truly two-way embedded system approaches as well, but you can do that. It's not an either or. It's a real complementary approach, and so. But because, and I say that from the perspective of leveraging some of the best practices we've seen from leading practitioners around the country. Rebecca talked about what's going on in Toronto. There's some incredible pricing things going on up there in Electra utilities. New Brunswick Power's done some incredible things around that. Just to speak to that. If we're talking about grid interactive buildings, what they've done in California with Title 24 to mandate that new construction be open ADR compliant, a lot of things going on there. So next slide is, I just want to, before you start thinking about piloting everything and maybe deploying nothing, I just want to caution you that there's a lot of folks doing a lot of neat stuff out there that you can leverage. We like to say the pioneers get the arrows and the settlers get the land, and the fact that there's a lot of publications that we put out, conferences we do twice a year, where folks talk about what's actually happening out there and the way the world is, maybe not the way the world should be. And so with that, I hope that, like to contribute to the discussion and turn the microphone back to all of you in the audience. So thank you for the opportunity to join you today.
Thank you, Ed, and really thanks to Kara, Rebecca, Dan, and Ed all. That was really great, and I think got us set up for a good and robust discussion now. And we were going to have, if you go to the next slide, spend some time having me try to recap all of those, but in light of the fact that we got started a bit late, I'm going to assume you're all listening. I will say that the NYSERDA team did also come up with a list of some of the potential barriers for us to consider that have come to their mind. I think they're all consistent with what you just heard. These issues are the upstate-downstate divide, which I think, Dan, you really pointed out. The cost and value proposition, which is almost every speaker brought up, and Rebecca, you really honed in on that a lot. The regulation, the uncertainty from lack of policy mandates to incentives, but that wide range of regulatory uncertainty issues, and then the issue of utility engagement with potential misaligned incentives, lack of price signals, resistance to change, all those issues. Some of that came up in the presentations as well. So rather than try to add on to that a lot, what I'd really like to do is get you all talking. I do want you to know that we've got about 30-ish people here in New York City. There's about 30 online, and last count there's around 7 of you in Albany. So I'm going to do what I can to make sure everyone's voice can get heard. It's great that we have such a big audience, which is why I want to dive right in. We're really looking to encourage you all to suggest the barriers you encounter and are aware of in this section, where we're talking about the barriers and opportunities for advancing grid responsive electric buildings and supportive policy and rate structures. So what are you encountering for problems, barriers, and therefore what are opportunities? We heard a lot of those from the presenters. Again, remember the ditto, but who'd like to hop in? Let's start here.
Will the slides be distributed?
Excuse me?
Will the slides for these presentations and the ones later today be distributed? If so, can you give us some idea when?
Yes, the slides will be distributed. We just have to ensure
So that was yes. We've got to make sure that the presenters are fine. They just spoke to them publicly, so I'm assuming that will be yes. Thank you. And remember to say who you are and who you're with, rather than have us do broad introductions. Who'd like to hop in? Yes, sir.
Hi, thank you. My name is Evan Berger. I'm the national lead for CalMac energy storage, thermal storage for, we're now owned by Crane. And so I run basin regulatory for us across North America. I also run the sales division for us here in the Northeast, spanning from Baltimore through New York City into New England and back. So, we have 25 megawatts of thermal storage here in New York and a gigawatt worldwide, one of the largest energy storage companies of any sort. Although actually I think the chilled water, the stratified chilled water storage industry is actually larger. So this is much bigger than batteries. The thermal storage world, very small, we keep to ourselves, but it's big stuff. So we have 25 megawatts here, I would say in spite of policy rather than because of it. And if we get this right, we can really accelerate the growth of thermal storage here in New York, which would displace those dirty oil and gas peakers that we've been talking about for the last few years, which is exciting. What I would say is, a lot of development here in the last few years. I've never sold a project before based on sustainability before. Now I'm doing it the last 18 months. It's amazing. It's really nice. A little belated and maybe too late, but we'll see. What I would say in terms of regulatory and policy is, one, Dan mentioned this, the billing, the way that the bills come out is incredibly opaque. We're not as bad as West Virginia, where they just have one line and they say, pay this rate, pay this amount, with no explanation of the demand charges. But there's no explanation on these bills. So, you see these charges, but you can't really tell the extent to which what they mean, and the times. And so I know that, the tornadoes, the SL Greens, they're pretty sophisticated users, but your everyday folks, they don't really know how to break these bills down. They just pay them. The second issue that I would bring up is that here and everywhere, it seems like there's a lot of great work being done on demand response, which is very exciting. Demand reduction and demand response are often at cross purposes. The regulatory environment kind of pits one against the other in terms of how we use our assets. You know, we have this thermal storage battery that we, charge for 8 hours a night, and we can discharge it for anywhere from 4 to 14 hours longer during the day. And, the question is, do we put it in demand response, or do we shift it every day? We generally prefer to shift it every day, but then that, sort of keeps us, because of the customer baseline and CPL issues, away from demand response. And so that would be a real good way to maybe accelerate how we can deliver value to our customers and grow this business, which I think we all want to do. Thank you.
Great, thanks. What I got there was working on getting the regulatory structures to actually promote thermal storage, addressing the very opaque nature of bills so that there's more transparency and information available, and then resolving the conflict between reduction and response on the demand side. Who else would like to hop in here in the city? A couple more here, and then I'll go outside. Anyone else? Yes, sir.
Hi. What's this for? Hi, Mark Ginsberg, Curtis Ginsberg Architects. I'm also on the board of 2 affordable housing groups in the city, and much of our practice is multifamily, much of it affordable. And there are certain things that are discouraging electrification. The single biggest one is landlords have to pay for heat. They don't have to pay for cooling. If you go to a system like a VRS system that does both heating and cooling, the landlord can back charge the tenant for cooling. But if the tenant doesn't pay, the landlord has to take them to court. They can't just shut down the system. So we have clients, as we're designing buildings, saying we've developed a way to do hydronic baseboard heating and window air conditioners. We're doing passive house, so we're trying to be very energy efficient. And you get this issue where the landlord is discouraged from doing an electric building because of how the regulations work. Tied into that also is doing master metering and sub-metering has the same problem. The other thing I would point out with affordable housing is it's very sensitive to capital costs. As capital costs are going up, the per unit cost is going up, and the state has goals for reduction of number of units. You get into the situation where you're getting pressure from groups like in the city OMB who say, we got to keep the costs down, don't make a greener building or electric building, which is more expensive in capital because of that. And so it's very important. The final thing I'd flag is even our fairly sophisticated developers, their staff isn't that sophisticated in operating a building. It isn't like a tornado. The buildings tend to be 50 to 100 or 150,000 square feet, and they have super and staff who are quite possibly very good, but are not particularly educated in all of this.
Great, thank you. So what I got there quickly is the kind of split incentive on the heating and cooling side with the landlord, tenant question, similar challenges with master and sub-meter issues, the policy disconnect of capital costs with other policy goals around volume. So we don't ever get to the operating cost savings because of that conflict, and then the need for some workforce development to improve operational capability.
I just want to add one other thing. Right now, you can't meter water for individual units. And we've looked at doing it for a project, and it would cut water consumption about 20%. Well, how does that tie into energy? There are pumps, heating, et cetera. So also looking at ways to, in effect, allow people to pay for their use, to limit their use would be tie into this.
Perfect, thank you. Sir?
Bob Wyman. I wanted to follow up the comments that were made about CalMac. And of course, the thing about CalMac thermal storage is they store cold as opposed to heat. But it's really important that people understand that a tremendous number of opportunities in storing heat as in thermal storage systems, thermal batteries as well. Also, we should recognize that in buildings today, the amount of heat that we waste is just criminal. Somewhere on the order, in a multifamily building, for instance, somewhere on the order of 20% or more of the total amount of heat which is generated is just flushed down the toilet into the sewer. And we have very reasonable technologies now for essentially reusing that heat, recovering it, and returning the water to the sewage system at the same temperature as it comes in the building, but taking that heat and putting it back into the hot water. In general, I think what we're going to have to do is we're going to have to learn how to manage our thermal resources with the same kind of sophistication that we currently manage electricity. Today, largely, we think that, thermal energy is a question of you light a flame, you heat some stuff up, and then who cares what happens next. And that may have worked in the past, but in the future, we need to be going around finding sources of thermal energy, sinks and sources, and managing them in the same way that we might manage loads on an electric system. So let's think not only about the wonderful stuff that CalMac does in storing coal, but also storing heat. Is it appropriate at this point to ask questions of the presenters, or?
I think it's fine to pose them. I don't know that we're going to have a back and forth because we're really just trying to get input. But if you had a question about something somebody asked, it'd be great to at least capture that.
Okay. Well, I would be curious. Ms. Kraft mentioned that the rates currently don't include all charges that make up the rates. I wonder if we get some expansion on what exactly that means. Also, it wasn't obvious from her discussion whether she was talking about consumption rates or volumetric rates in terms of the real time, which are primarily on the supply side, or where she was focused on demand side factors, which actually determine utility costs. And also, there was a comment made about a bunch of technologies being used to manage demand within the home. I wonder if we could get some elaboration on what that bunch of technologies actually is.
Rebecca, would you like to really quickly try to respond?
So a couple things. On the bunch of technologies, we're happy to make that public when we make a public announcement with the details of the pilot. We're not there. We're doing a lot of work on that. It hasn't fully launched in the home yet, so that's a few more months. On the rates, what we're doing is we're taking the IESO supply price from the market, and we're taking all of the utilities' other charges, volumetric, fixed, all the other charges. We're converting them to an hourly rate. And that hourly rate will move every hour in coordinate as demand on the grid increases and comes down. So there will be, if you saw a bill, it would not have a commodity charge, a demand charge, and other charges. It will have one price. It will be X cents per kWh, and that will be it. Everything will be filtered into that. So that's the idea.
Okay, if I could then follow up. I want to, for those of us, there's some of us are in the rate-making conversations a lot, and there are some concerns about real-time rates, which are focused on volumetric components, about generating inequities, and as a result, discouraging, particularly for high load factor applications, things like people that use heat pumps and such, essentially discouraging beneficial electrification by inequitably distributing the impact, the costs. It's very effective to do that inequitable distribution because it certainly does drive behavior, but the question is, do we want to be using inequities in order to modify behavior? And the other thing is, since we can't get a description of the bunch of technologies that will be used, I'd like to point out something that I think we should all be pushing on our manufacturers now, particularly in the residential sector. The fact that we have our market is dominated by volumetric rates based on kWh, means that manufacturers their control software, their marketing, et cetera, is all focused on their ability to be efficient in terms of kWh. The reality is, from a utility cost point of view, kWh doesn't matter that much. What you really care about is kW, which is demand. And I think one of the things that we need to be doing is we need to be pushing back on the manufacturers, particularly in states like New York, where we're beginning to deploy mass market optional demand-based rates, is to push on manufacturers of devices like heat pumps, electric car chargers, washing machines, et cetera, to expand the capacity of their control software so that they can not only optimize kWh, but also optimize kW within the context of the full building or full home load. So far, nobody has ever done that because there has never been a financial incentive to do so. Residential rates are almost universally purely volumetric, and so it is absolutely in nobody's interest to do the thing which is most important for optimizing utility costs, grid costs, and that is manage demand. But as we are beginning to roll out demand-based rates, it's time that we start pushing on the manufacturers to look beyond kWh and start thinking about kW as well, within the context of full home load.
Great, thank you. So what I gathered through all of that was that there is real opportunities within the thermal storage space, within the heat recovery space, there's a need to have thermal management catch up with the electrical industry, that there's a worry around volumetric inequity and real-time rates, and that we need our manufacturers to also be pushed on the kW side in addition to kWh. I'm going to go to the phone now. John Moore, if you're there, please unmute yourself and hop into the conversation.
Hello, this is John Moore. Can you hear me?
I sure can.
Okay. I had a comment regarding the kind of the incentives. One of the things we've dealt with is we would like to be able to produce more power on our campus with solar and potentially even wind, but at the current moment, the ROI is just not there for us to do that based on the utility rate cases. So some kind of, to me, that's kind of a barrier that I think we could do more to generate more, but we need to have the utilities kind of and the PSC helping us make that more a possibility.
Great, thanks, John. So the need to really look at the incentives around producing more renewable energy on site. What I got there. How about Albany? Is there anyone in Albany that would like to hop into the conversation?
No. Hi, this is Joe Brian Applegate from Pace Energy and Climate Center. I guess just like to comment on the use of wider use of demand rates. Is that's just to say that would need a complete sort of restructuring of especially how residential users interact with their appliances and their electric bill, and unless you're reorienting the entire home around a heat pump, and not that demand rates wouldn't make sense under a largely heat pump driven electric use, but for many people that's not something that they know how to manage, and there would need to be sort of a whole home control system that would need to be sort of rolled out first to make a wider use of demand rates sort of manageable for those people.
My name is Anthony Abbe. I'm a builder developer, and I'm also a BOE recipient, and I have a project, and many other of the BOE recipients are probably also having the same trouble figuring out the incentives and how we'll be able to use storage in these buildings that we have that are zero energy, where we do have on-site production, and trying to balance the peak loads of our buildings. And already a select group of recipients are having trouble trying to figure this out with a good development team. I imagine the hurdles that everybody else is having.
So let me just make sure I get this correctly on this last question. I heard that the incentives for storage, to make sure that we know how to use them. Is it a question around the incentives themselves, or is it a question around how the storage is played into the energy markets, or something else?
It's all of above what you said, and also just right now there is nobody that knows anything about how to implement this. One of the reasons why I'm up here in Albany is hopefully I'm going to try and meet with somebody at NYSERDA that has a clue.
There's lots of people at NYSERDA that have a clue, so I'm sure you'll find somebody who's probably sitting right in the room with you. Thank you for that clarification. Is there anyone else in Albany that wants to hop in?
Oh, hi. This is Danielle Panko from the Utility Intervention Unit. I took some notes, and I believe it was under the presentation by Dan Egan, and he mentioned that electrification would place a burden on the grid. I was just wondering if you could elaborate on that a little bit more, and if you have any research or anything that would support that.
Dan, can you do that quickly?
Sure. In the slides that will come around after the presentation, I provided a link that was to a report that was completed by London Economics that talks about the potential and, to assign numbers to anything that you don't know, you'll automatically be wrong. But sort of talking about the relationship between electrification and additional demand. So what we can see is a winter peaking grid that has all sorts of new implications for maintaining a grid that we aren't quite accustomed to yet. And then also how the peak itself, the grid peak, could increase when electrifying building services such as heat.
Thanks, Dan. And I think when the slides do come around, I think Rebecca's kind of cost basis slides speak to that as well in connecting the grid interactive efficient buildings operational costs back in to help reduce so much T&D. So I think Kara, sorry, I had the wrong person. I'm going to come back to New York City for a moment. Albany, if there's others there, I'll be back to you soon. Here in the city, would like to hop in. Yes, sir.
I'm Bill Axel with Con Edison. So I'll do a quick ditto on most of what Bob Wyman said, because I think what he was heading towards a discussion of cost-based rates and the importance of rates reflecting costs. I think in all these discussions, another thing that we should be cognizant of is whether we're talking about rates for supply or for delivery service, because they really are two different things with two different sets of cost drivers. And cost-based rates are important, as Bob mentioned, because the cost of the delivery system is mainly fixed and demand-based. And as Bob noted, most residential customers pay on mainly a volumetric basis. So if we're going to be doing more electrification, it's more important than ever that the price signals are right so that rates encourage technology adoption and customer behavior that benefits the grid, and that'll help control the cost of the grid for all customers.
Great, thanks. So this notion of making sure that we get the cost-based rates correct, and whether they're delivery or supply, and the last point, which is vital, is this notion of getting the price signals right, because it's vital to drive decision-making by consumers of all types. So thank you. Who else? Yes, sir.
I'll hop in. Toby High, National Grid. So in addition to, I think I'll dig down to Bill's point about network versus supply costs. But the other thing that triggered is when I think about our commercial classes not settling on their actual usage on average load profiles, and it wants the incentive to manage your own usage. So obviously that's tied to expansion of interval metering and utility billing systems. So when we think about sort of where the returns and incentives for buildings to operate efficiently, that's a pretty big gap for a pretty significant swath of customers.
Perfect, thank you. Who else here in the city?
I'll add a comment as well. Dan Egan again from Vornado. I think that the export rate such as SC11 is not an effective motivator when we're considering something, you know, on-site DER or other renewables. You know, when it comes to sizing, so Greg mentioned, you know, we have a 55% capacity utilization rate. That comes right down to the building. You know, commercial buildings in particular are pretty inefficient with how they use their power. And the sizing of on-site generation is often limited, economically speaking. Well, also from a regulatory perspective, whether export is even permissible. But to, you know, have a nickel per kilowatt hour of what's going back into the grid doesn't really send the signal that DER is something that's going to be counted on as a reliable component of balancing the grid. I think that's something that should be looked at.
Great. So this notion of are we valuing the export rate correctly is brought up. I also wanted to point out a number of you have been negligent in thanking all of you who have used the ditto language. So thank you for that. Keep encouraging that. Let's go back to Albany. Is there anyone else that would like to hop into the conversation?
This is Joe from Pace Energy and Climate Center. I guess with respect to the sort of cost and potential studies for electrification's impact on the distribution system, I guess do they take into account, I guess, sort of locational constraints versus overall network constraints? I know that some utilities in the state have more than double the peak capacity on their system as a whole that they actually are utilizing currently. And so at what point of electrification do we actually run into widespread distribution constraints? And to what extent are those sort of, would those be just locational constraints at certain points in the network?
Right, so I think that what I think I heard was that, a question around how deeply are we looking at those locational constraints down into the distribution network, and is that being done robustly enough? I know this is always brought up when we all have electric vehicles and show up at home at 5 o'clock at night. Are we just going to be popping transformers all over the place? And are people thinking about that and the other types of locational issues that can arise on the distribution side? We always talk about transmission. Rarely do we dive into distribution. So I hope that captures what your comment was. Anyone else in Albany?
This is Jillian Casso at UIU at the Department of State. Just a general question to the NYSERDA organizers. Could we have a list of the participants for this session? I don't think there was one that was sent around, just so we know who's present and who's weighing in.
Yeah, they can be made available. Are you thinking after the session or?
Oh, yeah, that would be great.
Yep, perfect, we can do that.
Thank you.
This is Joe from Pace. Just to clarify, I wasn't trying to say even so much as are locational constraints being taken into account, but is current overcapacity being taken into account as well?
Great, thank you. I missed that. I appreciate it. That's why, so you know, the reason I try to say these back a lot is that if I'm hearing you one way, probably a lot of people are, and so then it gives you a chance to say, no, you didn't get it at all, which is probably 90% of the time I won't get it quite right. So thanks. Let's jump back to the city. Actually, I wanted to go online, sorry. JP Flaherty, please unmute yourself and join the conversation.
Sure. So JP Flaherty from Just Inspire Properties. I am our Director of Sustainability and Utilities, and I just wanted to reiterate some comments that Dan Egan had made about the STEAM system, and that, I think Dan summarized it very, very well, but I just wanted to throw my 2 cents in that I really believe that solving the STEAM issue is absolutely critical to this overall conversation, because the majority of Midtown office buildings are heated by steam, and that is a humongous potential electrical load. If all those steam heated buildings in Midtown went and electrified their heating systems, the amount of money we would need to spend upgrading the Midtown electrical grid would easily surpass, in my non-expert opinion, the cost of turning the steam system into something better. And there's lots of places you could go with the steam system. I think people forget that district heating is extremely common and widely used throughout the world. The United States is unique in, maybe not unique, but is very much behind in district heating. And Con Ed district steam is very much behind in district heating in the world. And there's lots and lots of things we could do to make the district steam system better, but abandoning it is not a good idea to go to electrification, as it would require massive investments in electrical infrastructure that I firmly believe would be better spent upgrading the steam system. So I know it's kind of a tricky issue, and it's something that we've certainly talked to NYSERDA about before, but I want to highlight that solving and cleaning the steam system or providing clean district heating is the answer to that problem, and not electrifying the heating in all those buildings, and that's an area that we really both need to spend time and money on, and understand that the incentive structure that Con Ed faces is not conducive to this. Because guess what? Con Ed sells steam, electric, and gas. So if the steam system wasn't there, Con Ed would still be selling just as much of the product. So they don't really have an incentive to solve this problem. And therefore, I really believe that it's the state, who has to sit in the driver's seat of figuring out what to do about steam. And I certainly firmly believe that the answer is not bailing on the steam system, but creating a modern district thermal heating system.
You wanted to add to that, you said? Yeah, I would like to suggest that in the comments that were made before, that the focus should be on a modern thermal system as opposed to a steam system. Steam systems have, are fine. They're district heating systems, that's great, okay. But steam systems have particular challenges. One of the ones that's being faced by Con Ed, and they've outlined very clearly in their long-range plan, one of the reasons why the steam system won't be growing in the future, is that in a place like New York City, it is just massively expensive to be digging up the roads to put in the large pipes that are needed for steam. On the other hand, we have tremendous opportunities in New York City and throughout the state for district heating systems. Particularly, we think geothermal district heating systems, and that's why in the current joint settlement on the Con Ed rate case and in the City Council with legislation, et cetera, there are going to be pilots for geothermal district heating and for non-steam district heating within the city, and we're hoping that other parts of the state follow on that. Also, if you look up in Massachusetts, you'll see that the gas utilities up there are working very closely with groups like Mothers Out Front and state agencies to explore the opportunity for replacing either the entire or at least large parts of the gas network with district heating systems, which would be non-fossil fuel based. Now, these are anticipated to be non-steam district heating systems. So I think we will probably need to accept that while we'll be using steam for a while, it is in fact low temperature thermal systems, which will probably be the most useful for us in district heating in the future. And yes, it is shameful that the U.S. is so far behind on this technology. If you go someplace like Sweden or Denmark, Sweden's certainly colder than here, you'll discover that they use tremendous amounts of district heating. In places like Denmark, they've even banned all fossil fuel heating in buildings. They're doing the same soon in the Netherlands. We need to get up with the technology like the rest of the world and stop being so far behind on technology. We should be putting a tremendous amount of effort into district heating and cooling, but it should probably not be high temperature steam. It should probably be low temperature resources. And hopefully more sustainable ones like those that rely on geothermal as opposed to combustion.
Great, thanks. Let me just, before I go to other folks, let me try to get a NYSERDA resource. My memory is telling me that there's a separate event plan to talk about district heat and steam. Is that right? Am I recalling that correctly? Yes, I have heads nodding yes.
Correct.
Just so you all are aware, it's not to say don't raise it today in the context we're here for. It's not to shut any conversation down, but rather simply just to let you know there's agreement that this is a big issue and actually needs a separate conversation. So that's coming soon. Maybe at the end we'll know a date. I wanted to stay online with Indu New. Unmute yourself and join.
The one challenge I see that we might face as we move forward with beneficial electrification is a move towards winter peaks, and we're already kind of seeing it where during cold snaps we pay a lot more for that electricity than say even during summertime peaks, and that's going to increase because wintertime is also where some of the renewable energy sources such as solar might not be contributing as much. So I'm just wondering what effect that would have on how dirty that energy is, the wintertime energy and the rates that customers would pay for wintertime energy use.
Yeah, so the worry about with increased use due to electrification in the wintertime, cohabitating with lower generation from renewables, and what does that do to how much dirtier electricity we're using? This is a comment there, I think. That's what I got. I'm trying to get people for the first time, so I know a couple of you are wanting to come in again. Let me just check around the room here in New York City and see if anybody else would like to join the conversation. And how about in Albany? Anybody new?
Yeah, this is Anthony Abbey again. Yeah, I would like to ditto what the last caller said. Our speaker. What is the plan for the great? Right now we have peak summer electric needs, and as we electrify the grid, it's going to be moved to the winter and probably be longer periods and more duration. That's something I'm just wondering, and that's one of the reasons why I think, as we do more buildings and renewable installations, more local, maybe microgrids and battery storage might be needed to store up for those moments.
Yeah, so I think we got that that move to the wintertime and the impacts of that and what are the possible solutions. So I presume the roadmap would in some way address that. John Moore, would you like to join the conversation again?
I asked, I posted a couple of them, but so one of the questions I had, maybe it's more of an opportunity, but the general science consensus regarding increased utilization of water source geothermal systems rather than having to drill. I know current policies, it's very difficult to use water source, but is that science or the opinion of science is that gonna change in the near future?
So the question is around the use of water-based geothermal, is that what I understood?
Correct. So we do, we certainly have a lot of water sources available to us, and the cost of utilizing the water is much less than it would be to drill for geothermal. And I just don't know where that science is going in terms of, the certainly you're going to warm up water sources to some extent.
So the suggestion is that be investigated as part of this road mapping to determine the efficacy of doing that and whatever barriers are in the way of that today. So the way I would frame that into a barrier/opportunity, if that's helpful. You want to come back in?
Thank you. This is Devin Berger from CalMac Train again. I just wanted to first comment on Bob's good points. We actually do have a heating solution called the storage source heat pump. We have never used it.
Where did you do that?
We have actually done a few applications, but we have to pair ourselves with third-tier natural gas. So we have really very little, until now, which is why it's exciting. We're here at a electrification conference in Quebec and in Eastern Canada. They have very cheap hydro, and so they do heating with the electric grid. We don't do that here almost at all in the United States, and so that's why we haven't done it. But we actually do have a way of using low temperature heat on one side, so it's 95 to 100 on one side and 22 degrees on the other with the heat pump technology. So wanted to say that. I thought, just going back to what Mark said before, he mentioned that there are two different issues regarding the supply bill, the third-party suppliers bill versus the, the utility and the distribution bill. On the supplier side, right now, most customers do not see a broken out version or a broken out itemization of their ICAP, their New York ISO capacity obligations and what that's costing them. Oftentimes that's a very significant, maybe 15, 20, 25% of their electricity costs. And so they don't understand that, they don't see it. And I think, some policy addressing, mandatory explanation or showing of that would be very beneficial to customers statewide, particularly those who are less, your everyday customers like a school or a hospital that just doesn't have advanced energy management capabilities on staff.
Great, thank you. So that mandating that the supplier ICAP be broken out of the bill is the suggestion on this to take up. Online, I've got John Ciavaca. Sorry, I'm terrible at this.
Oh, that's all right. I'm John Ciavaca. I'm with Aztec Geothermal and IGO. The water source heat pumps, geothermal heat pumps are water source heat pumps. They're just tuned to take a lower temperature water typically, but it's really the same basic technology. And then there's different variants of it. So I don't fully understand the question about about water source heat pump technology needing to catch up. We certainly can use surface water, and there are many different energy sources. Buildings next to each other that have diverse loads can share instead of going to deep drilling. But a lot of times the combinations of things in district systems in dense urban environments will be a combination of some type of larger source, could be a body of water, could be drilled closed ground loops, and then the buildings themselves will interact with each other. It's always surprising to people that large buildings have a large air conditioning or chiller load, even when it's quite cold out. That will throw heat into the system that then can leverage the efficiency of heat pumps in that building or other buildings if they're in a network. So there's also high temperature technologies that are less well known in heat pumps. There's certainly CO2 as a refrigerant can reach temperatures close to 190 plus degrees Fahrenheit under certain conditions. In Japan, they're doing a lot of work to get electric heat pumps to produce steam. Right now, those applications are really too small for the scale of, say, Con Edison's steam infrastructure. But these could be ways that, say, a condensate return could be raised up through an electric heat pump technology reasonably efficiently, and then maybe finished off with combustion in an interim basis until the steam infrastructure maybe gets replaced. Certainly using electric resistance to produce steam, I don't think anybody thinks that's a reasonable approach. We certainly need to leverage the efficiency with heat pumps.
Great, thank you. And last word for this first piece before we get to break is, so you want to hop back in?
I just wanted to quick, I think, John, the guy who was talking before about that, he was looking for an alternative to drilling. And of course, a lot of the water source opportunities are there, but yes, geothermal often requires drilling. In addition to the water source opportunities that John mentioned, I think I'd also like us to remember that sewage water is an opportunity. And frankly, it's a little weird, but actually the potable water, just the normal water supply, is currently being used out on Long Island to provide heating and cooling for a school out there. It's an experiment by American Water, where they essentially put plate exchangers into the drinking water supply. And of course, they have to be very good and very leak-proof plate exchangers. But the point here is not to encourage people to be sucking heat out of our drinking water, but rather just to point out there are phenomenal numbers of opportunity to be pulling heat out of or pushing heat into the environment to and from our buildings, most of which nobody has ever taken any serious
look at exploiting. We are surrounded by wasted heat. We are surrounded by opportunities to provide cooling, et cetera. And the various heat pump related technologies we have are going to be really good and are going to allow us to start capturing all that wasted energy. Anyway, there are also, I'd like to, if I could just comment on the issue of winter peak. I don't think anybody questions that we're going to end up shifting from a summer peak to a winter peak. The reason we're going to do that in part is because we're going to be having more efficient cooling during the summer, and we're going to be shifting load from fossil fuels to electricity during the winter. So our summer peaks are going to go down relatively, or at least on a square footage basis. Our winter peaks are going to go, our winter consumption is going to go up. But this is not necessarily a bad thing. Also, it's not necessarily something that's going to happen tomorrow. For instance, I've done work on modeling this out in the single family business and single family market, and I'll show like in an area like Orange and Rocklands, which is just above New York City here, it would take a 55% market penetration of geothermal heat pumps before you would add your summer peak move over to your, the annual peak move from summer to winter. Of course, it would happen much sooner with air source heat pumps. Air source heat pumps should have about a 14 to 15% market penetration, and that's when your peak will shift from the summer to the winter. But understand with geothermal and high efficiency technologies, 55% market penetration before you get the summer peak moving to winter peak. That's a long time from now, a very long time from now. And we'll have plenty of time to respond and plan for how we build the resources needed to address that winter peak when it happens. So it's not like we've got an emergency situation here. We've got, as long as we don't install too much of the inefficient technology, we've got plenty of time to prepare and build out what we need.
Great. So the last couple of comments are really talking about how we begin to imagine ways to share the heating and cooling excesses in both bidirectional across buildings, thinking about new types of sources to share, really begin to reimagine things in some new ways. And I just say in the Game of Thrones vernacular, winter is coming for the peak, but we have some time before it gets here. I'm going to close this first half of this first session today, and we'll restart at 5 after 11. And just to give you a sense of the topic, so you can think about it as you grab coffee or do a bio break or what have you, we're really going to be focused on how utility rate design, programs, policy, and regulation play a role in paths forward for New York State today, 2025, 2030, 2035. So, how do we move forward from here? That's what we'll jump back into when we reconnect. So we'll go on mute here for a bit, and Albany and online we'll be back in touch with you shortly. Thanks all. 5 after. Thank you. Thank you. Oh, good. Thank you. That's even better. All right. Before we dive in, I don't actually have a poll in yet, so I'll do that when they get back. So we're going to jump in now to this question again of how should utility rate design, programs, policy, and regulation play a role in paths forward for New York State. And here's the goal that I'm trying to get at with you all to help frame things a little bit. So looking to get you all to contribute innovative ideas, goals, and research that can push government to move out of the business as usual approach and reach carbon neutrality in 2050. So now step beyond the barriers and let's start talking about what more do we need to know, what goals could get set, what regulation could be put in place, and that's where, the type of dialogue that we're looking to get to. One thing just from a design perspective, I noticed in the first session, people at the table spoke, nobody in the audience spoke at all. That's normal. Probably the introverts sat in the audience behind the table. That's normal. You'll see now we have a lectern. So when I'm in here at the city looking for respondents, This is not a requirement that you all enjoy the conversation and engage, but it's an invitation, if you will. So just queue up there if you're interested in joining the conversation, and when I can, I'll get to you. So thank you for that. I want to make sure whether you're online in Albany or here that we hear everybody's voice, and I'll do my best to get that out of you. So on this first screen, you'll see a few questions, and I'm not necessarily going to start by jumping right into the questions. I'll come back to the questions if we're not getting a lot of input, but you'll see, I think they're useful for you to be looking at, and there's a second page of them at some point if we want to see them, but to try to help prompt your conversation. So I think what I'll do first, with the introduction I've offered, is we've heard a lot of areas this morning, so now flipping that forward, this notion of what can we do, learn more about, set goals for, set regulation on, to try to move us forward here in the state of New York. And I know I've got Kara Carmichael on the phone, so if you unmute yourself, you can begin us.
Sure, great. Thanks. I think this is a really great discussion, and one thing that I'm hearing this commercial real estate investments and upgrades are a little bit stalled, and that's concerning. And I hear the hesitation, and I understand it's for a good reason, but I feel like in a future with time-varying rates, potentially emissions-based or cost-based or some combination, I think that's going to result in kind of more variability, less concrete answers for building owners to make investments based on. And so it seems like an investment focus should be more on flexibility that would enable buildings to shift depending on how rates change, how emissions on the grid continue to change in the future. And I guess my question is twofold, like, are those types of solutions known enough in the building owner industry to kind of overcome this little bit of stagnation? And how can we work together to build flexibility-based incentives and rate structures?
So the piece of this I'm hearing is a need to make sure we can characterize that commercial market better in terms of their readiness for flexibility variable type rates for sure in there. And then if it's known and then second is how do we build those in a way that gets the incentives right and the pricing right that will drive that sort of investment. Is that a fair recap?
I think that's right. I would emphasize load flexibility on the building side, I think is the ultimate goal, and that we can start incentivizing today. We don't need to wait for emissions factors to become more clear in order to make those types of investments.
Great, thank you. All right, you're in New York City. Who'd like to hop in?
I think, so this is Evan Berger, CalMac Trades. I work with a lot of building owners, and building owners can also weigh in on this. I think there's a lot of, when it comes to designing buildings designing equipment that lasts a quarter century or more, risk mitigation is a big factor. And not just on a corporate level, but also in terms of on a personal level for the folks who are designing buildings, who are making decisions, who are writing, 7-8 figure checks. So in the absence of clear policy, the least riskiest option for folks who are making procurement investment decisions is to stick with what currently exists. So unless there's a real, true path forward, and unless they know what the actual rates are going to be, what the system design is going to be in 5 years, they'll default back to the existing system because that's the least risky, that's the best way to mitigate your personal risk as the procurement entity.
So a need for real clear policy. What I heard, and I want to make sure I got this because if it falls short, I want to then push you a little. Is that the pieces you gave me were on rates and system design? Is that a wide enough band of policy to move that barrier out of the way?
It's wide enough presently, but obviously we're looking at carbon in the future. So now all those related issues become also part of the calculation, which is exciting.
Great, thanks. And you're probably already noting what I'm trying to do with my questioning is frame us into what do you really need, right? Whether it's research, whether it's a market characterization, whether it's clear policy, trying to get us to focus there. So go there if you want. If what you've got in your head is I need this fixed, just say it and I'll try to turn it into a need or policy speak for you. Either is fine with me. Who else? Oh.
I'm Bob Wyman. Yeah, a couple comments. One of the things is when we talk about rate design, one of the things that inevitably comes up is the subject of rate classes. And at the moment, we have a very, very crude sort of categorization of rate classes that is historically made some sense, but I think we have to accept that in the future it won't. For instance, now we pretty much distinguish between residential, commercial, and industrial. But it turns out, for instance, if you just look at, either residential, commercial, or industrial for the moment, a building which uses fossil fuels for heat or for cooking, okay, behaves very differently than all electric buildings, okay? And this is particularly the case in the residential market, where residential buildings often the majority of the energy which is consumed by the building will actually be provided by fossil fuel. It will not be provided by electricity. But if you make that an all-electric building, you switch to, say, heat pumps, now it's going to have much greater electrical consumption. It'll have lower energy consumption, but much greater electrical consumption. And it'll do things like it'll peak its load during the winter rather than during the summer. At the moment, our rates basically treat a fossil fuel heated home and a heat pump heated home precisely the same. This doesn't make sense because the load profiles for these different classes, these different styles of home are completely different. Now, it makes sense today that our default rate, say the SC1 rate 1 in Con Ed territory, is a volumetric-based, KWH-focused rate, because that's the kind of technology that, for instance, we do have, for the people that have fossil fuel heating, their usage is, in fact, homogeneous as a group, and much of what they can do in terms of optimizing their consumption is by changing the volume of electricity they use. If you then start bringing in the homes that we wish to see in the future, heat pump driven, not fossil fuel focused, it ends up being virtually impossible to have a single rate which addresses the needs of both communities. So I think what we need to do is we need to realize that by 2050, we're probably going to end up in the default residential rate, and it's probably going to be, as commercial rates are today, it's probably going to be a demand-based rate for delivery. It will probably have time of use or real-time components for supply. And the people who live in those, and the reason for that is because we will have replaced much of our fossil fuel heating systems with heat pumps. But today, if you were to impose those rates on people who were using fossil fuel systems, you probably have, first of all, a tremendous amount of confusion, a tremendous amount of an education requirement, and all kinds of people simply not being able to adjust to the new rates. So I think we need to look forward, and we need to understand that not only is our sort of energy consumption technology in buildings going to change over time, but also our assumptions about sort of what is the correct rate for buildings going to be. Today, volumetric rates are the norm. By 2050, I think they will not be the norm. By 2050, I think we'll be on demand-based rates. And we need to manage the process of moving from today's technology of fossil fuel heat to the future technology of heat pump heat. And understand that there are going to be these two different classes of rates. And one of those rates will be declining in use, the other one will grow. The other thing I'd like to warn about is there is a significant risk of over-signaling. We like price signals. Conceptually, it makes a lot of sense. The economists tell us that that's the right thing to do. But you have to be careful about trying to match the frequency of your signals with the frequency, with the response rate of the consumers. A lot of the things that we are trying to get people to do, for instance, like replace your oil heating system with a heat pump, these are decisions that they get to make once every, say, 10, 15, 20 years. And the important thing is we want to give them signals that will motivate them to make these multi-decade decisions about as core technologies that they're using in their buildings. It doesn't do us any good to say be signaling them every 10 minutes or every hour or even every day or even frankly every year about, give them price signals, because they are going to respond with a frequency that is measured in multiple years or multiple decades. And so we have to be careful, at least on the delivery component of the rates, to be careful not to over-signal, because frankly, we're just wasting a lot of the signaling. And here we have, once again, a potential distinction we can make between the technology of the past, which was fossil fuel heating, with a couple of high-intense energy consumption technologies like air conditioning and things, where those people you may wish to have a very high signaling frequency, essentially continuously remind them, use less of this stuff and do it now, and you can do it by turning off lights, you can do it by backing off the temperature on your air conditioner. But then you have this other class of people who maybe are into, who have adopted, say, the technology of the future, beneficial electrification. They have their electric car chargers, they've got their induction heating, cooking, they've got their heat pumps. And those people, the real focus you want to have on them is to get them to make the switch from the old class of technologies to the new class, and then give them sustaining signals. Primarily, I think, is by making sure that they're being fairly allocated the cost of the network, as opposed to being reminded every 10 seconds and being given new signals, at least on the delivery side. The supply side, sure, signaling is important. But we need to be careful here when we're doing signaling to understand that over-signaling is not useful. We need to adjust the frequency of the signal to the technology base that we're speaking to, and we have to understand that we probably need a bifurcation in our rate policy, bifurcation of the rates, essentially dividing for both, at least residential and commercial, dividing them into those customers who are using the old fossil fuel technologies, who have one set of load patterns, and the new customers who will have a completely different set of load patterns. We need to deal with those groups distinctly, not only in rate structure, but also in things like the frequency of signaling. And just one last point, something that would really help us move in this direction is if we could begin to give people a clear statement that they will not be able to use fossil fuels in the future. We've already in New York City banned number 6. In 2030, we're going to ban the use of number 4 oil. We should have a schedule for when we're going to ban the use of number 2. I'm not saying it has to be tomorrow, but we should tell people when that's going to be, and we should tell people when we're going to stop allowing them to use gas. This also relates to rates. At the moment, we have a very serious issue in our gas rates, in that the gas rates at the moment are ridiculously low compared to the actual costs which are being incurred by gas consumers. And the primary reason for that is we have things like Local Law 97/2019, and we have the CLCPA, which tell us very clearly that by 2050, we're going to have to substantially reduce the amount of gas which is consumed, and thus the amount of gas which is sold by our gas utilities. Yet, a utility like Con Ed uses 85 years as the period during which they'll do cost recovery on new infrastructure, which is installed in the ground today, for mains, 65 years for services. And it is very clear that we're going to have tremendous amounts of stranded assets in the gas network. The result here is that there's essentially an intergenerational cost shift where the current consumers are not paying the full costs of the assets that are being built out for them and being maintained for them. So they're paying much less for gas than they should. You should understand as well, it's not only an intergenerational cost shift, it's also an interclass, economic class cost shift, because what we're seeing is that the wealthier people, the people who have access to capital, are in fact beginning to make the move from the fossil fuels to the heat pumps. And the gas network, we can anticipate over time, will become more and more dominated by low and moderate income customers, who essentially will be the ones who will be exposed to the rapid increase, inevitably rapid increase in delivery charges as the largely fixed costs of the gas network are being carried by fewer and fewer people and being spread across fewer and fewer therms of gas being sold. So we should, when looking at this question of rates, we should not only focus on the fact that we have this inevitable bifurcation, need for bifurcation in the rates, splitting between the old and the new technologies in the future, but we should also understand the interaction between the electric system and the gas system. Right now, the rates in the gas system are way undercharging the current users for the assets they're consuming, for the benefits they're gaining. If we were to get more equitable gas rates, it would put a tremendous amount more pressure on the electric system. By the way, I just want to say, no, I'm not trying to encourage, screwing people by dramatically increasing their gas rates. Just want to point out that this is a fact, that we have we have many billions and billions of dollars of stranded assets that we're beginning to pile up, and efficiencies and depreciation. And we should be addressing that issue and understanding that these stranded assets are real costs that will be borne by ratepayers in the future, and the stranded assets and the real costs of gas should be considered as we are making policy on the electric side as well.
Great, thanks. I think I got about 5 key themes there, just to restate them. At the top was the notion that we need to manage from the need to move from a volumetric to a demand system, and that the management and bringing people along and understanding the depth of knowledge so we can move towards that which we need in a logical way. Second is this notion around over-signaling and the need to break the system kind of apart into the fossil-based versus electric-based, and making sure that we're signaling the appropriate rate classes in that way, so that we get the desired outcome, signaling people on the one path a lot and not so much on the other. Then there's this notion of making sure that getting clarity from a policy perspective around when we're going to be transitioning out of a fossil fuel future, and when that's not going to be available anymore. That is real impacts for consumers making their decision making, but then a whole range of stranded asset questions and future investment questions for utilities. And then the last point brought up was, I characterize as an equity justice issue around this particular challenge of who's left to pay for the natural gas system that's available in the future. The very top overview, I'm sure I missed a couple of the sub points in there, but yeah. Albany, thank you. Oh, go ahead. Before we go to Albany, one other here in New York City. Come on in.
Hi, everyone. For those of you who don't know me, I'm Jenna Tatum, and I used to work for the city of New York. I now actually work for cities across the country on building electrification. One thing I just wanted to sort of build on Bob's great points here, just around the nexus between affordable housing and electrification. We work with cities where neighborhood change and gentrification is the issue that they have to deal with, including in New York City. And I think that I would just encourage us all to look for solutions that encourage both electrification and more affordable housing, and really think about those two together in some ways is sort of making our problem bigger, which I understand can be scary, but I don't think that we solve this problem without being clear that housing that we're seeing today is not affordable to people who live here, and we can't afford to make the problem worse, and it's even better if we can find solutions that do more of both. So I would, in my head, I kind of split it up between the new construction side, really building all electric from the beginning. There are reduced infrastructure building costs from building all electric because you don't have to bring gas lines into the building and throughout the building, but then we also avoid some of the stranded asset questions. In some ways, that's a little bit easier to solve, but yeah, I don't see it solved right now. And then I would say that I think in terms of preserving affordable housing, there's a lot of affordable housing that is government subsidized today, and we need solutions like utility allowance reform to help with those buildings. But I think we also need to look at the naturally occurring affordable housing that exists in our cities and find ways to present more of that and make, upgrades to improve housing quality at the same time. So looking at ways to partner with HPD and HTC in the city and then HDR at the state level. So I don't want to go, I could talk about this, but I don't want to go too far into depth, but just kind of teeing those ideas up for us to consider.
Great, thanks. So this notion of really thinking about affordable housing and electrification as one problem instead of multiple problems and joining them, a recommendation that we get some clarity about the new construction that is going to be all electric from the beginning, and then this lastly, when we're remodeling, we look at the utility allowance reform, we create utility allowance reform to help those retrofits happen in a more simple fashion that pencils out better. I think we've got that. Let's go to Albany next.
I think we're all set in Albany, thanks.
Okay, online I've got Indu.
Hi, this is Indu from SUNY Albany. I had one comment on the utility rate design. As we build out renewable and storage, does it make sense to incentivize buildings that can match their loads and on-site generation to the grid's capacity to supply and deliver carbon-free electricity? But as the penetration of renewables with storage increases over time, maybe the rates are structured to incentivize buildings with higher load factors that kind of even out the loads and increase system efficiency.
Great, thanks. So I think what I got there is right now it's incentivizing load and on-site generation, load demands, on-site generation makes sense, and over time, transitioning that to a higher load factor incentive. Is that right?
That's correct. Yes, thank you.
Perfect. Thank you. All right, let's come back here to New York City. What's in? I'm sure somebody does. And you're grabbing a mic. Go for it.
The mic. This may go without saying, but this is a very erudite conversation on these topics. These concepts need to be distributed to everyday ratepayers, and I think that these concepts need to be translated into sort of basic, more broadly understood terms. So whether that means, if we're going to talk about load factor, I think that the utility bill itself should explain a little bit about what that means. We're going to talk about time of use. There should be some illustration about, how the carbon intensity of power differs from one period of the day or period of the year to the next. I think that, not to, I think it's worth just spending a moment to address the fact that motivating the individual's participation in this is going to be key, and to the extent that that information becomes easily digestible on the bill, this might not be the right forum, but that tariff changes should be translated as such.
Great. So making sure every individual understands, and the note I wrote down is in D1 with the language, and make sure we can talk about this in common fifth grade English so that everybody gets it, and to help kind of with the movement as well. Who else? Let's just look back at the questions again, and so I'll prompt you a bit. Do I have somebody? Yeah. Go ahead. Oh, I'm sorry. No, go ahead. Question. Come on in. Come on.
This isn't so much about the building as opposed to, how do we start to rethink some of the great business approach. Sorry. To me, one of the things that certainly was frustrating when I was in utility was the real the lack of flexibility to test things in a reasonably real time, and the ever ongoing adversarial nature of everything that you want to do. And that's from a pilot to a rate case. I don't think we're going to make any progress on anything around rates or new utility systems until there's a way to rethink that process. Because there are too many vested interests who will not budge. I mean, even this room, I would say Bob and I probably agree fundamentally on a lot of things, but what I said, I think he heard differently. And if you're in an adversarial proceeding, you can't have a conversation around that is public and it's open. And so trying to get away from that and trying to get some flexibility, including commission staff and others, to participate openly and freely in informative discussions and come up with small bites that you can test, has got to happen. Otherwise, I don't think we're going to get anything.
Just so I can characterize that, she referenced you. So what I got there is we've got to find some different ways to test things that increase the flexibility of the participants and address vested interests and really help to at least be trying things. I'm thinking, you talked about Toronto and so why don't we try something like that, right? That's probably what's in your head. So since you referenced you, come on in.
Right, yeah, you're absolutely right. It's sort of funny to hear those comments in this room because this is the room where a lot of these battles and adversarial things go on a regular basis. I just want to give you one example, for instance, of some of the things that I mentioned today. Thinking about that bifurcation of rates and having different rate structures for the people who are using the technology in the future, I believe, and I think a number of the utilities believe as well, that getting more of a demand-based focus for delivery is important, as well as getting more of a focus on time of use or more real-time rates for supply. The difficulty is there, and I think people have done studies like Eric or NYSERDA has done studies showing, I think for, although the number is somewhat questioned, just to give you the number from the NYSERDA report, in the Con Ed area here, if we were to have, fair rates, rates which properly allocated costs, the expectation is that somebody who installed a geothermal system in a single-family home with a proper allocation of costs would pay something like $827 per year less for electricity than they would with the current rate, which of course sounds great if you're about to install a geothermal heat pump system. You're saying, yeah, I want to save $827 on my rate. But the problem is, while we can go through all the arguments and we can say that's a much more fair rate, that's actually, a more equitable rate, because it's essentially removing the subsidy, the reverse cost shift. Essentially, you're saying that the geothermal customer in the future won't have to do what he's forced to do today, which is essentially to subsidize the use of electricity by fossil fuel users, okay? Removing that inequitable subsidy sounds like a good thing, unless, of course, you represent the interests of people who don't have heat pumps. And we are in these conversations regularly where we're saying it would be much more equitable if we had rates which properly allocated costs and focused on cost causation. But then you get large numbers of groups who are saying, wait a minute, if we are more fair with you, that is going to increase other people's rates. It essentially is going to decrease the unfairness of their rates. It will force their rates to also become more fair, but their rates, if they are more fair, are higher rates. Well, the heat pump rates, if they are more fair, they are lower rates. And so we get this tremendous pushback of the groups who are defending sort of the status quo because the inequities, the inappropriate allocation of the costs or whatever that are in the current system serve their interests. Okay. And so, yeah, we have here, tremendous battles on a regular basis on these issues. It's one thing to figure out sort of in the abstract, what should the rates be? It's a completely different question to determine what can the rates be. Because what can the rates be is a question of the political environment as opposed to the abstract theoretical environment that we might wish that we were using when setting rates.
Great, thanks. And I think there's a couple pieces in there, and I'm right here, Mark. that I'm hearing between what the two of you said. On this latter point, I think, there's potential that there could be, as long as I'm supposed to look for the research, some look at, where, and maybe this is well known in the state of New York, I don't know, but some look at where is the real true cost basis and the rate structures that exist, and what would parity look like. Forget about what can happen, at least start with understanding what's the basic truth, and that could be something that could be built upon, because then all policy, there's winners and losers from, so then you decide where are we today, where do we want to get to, and that's where your can kind of comes in. And then I just wanted to add a point to the pilot piece, having run a startup company that got engaged in pilot after pilot after pilot. There has to be something after pilots, or your new technology companies just go away. And so when we think about how do you test, there's a piece of this, which is how do you actually move from pilot to something after that in the system that I just wanted to point out. And Mark, you want to come in?
Yes, I wanted to raise something. When you do a rental building, particularly if the developer is planning to own it for a long period of time, they're conscious of the future. When you do a building, either single family or I'm thinking more of co-ops and condos, where a developer is building it and selling the units and gains nothing by efficiency, trying to keep costs low. And quite honestly, people are buying, look at the bathroom fixtures and the kitchen appliances, not how efficient or how electric the unit is. I think there is a major public education program that should be done, potentially tied in with purchasing and educating purchasers so that they know the right questions to ask and understand the answers. Because otherwise, they're going to just buy what's pretty and not, or has nice appliances and not what's energy efficient or all electric, et cetera.
Great. So, particularly with these with turnkey development, where the owners aren't going to, the builders aren't going to stay in it, you focus on the carrots side rather than the sticks. I would say you talked about educating consumers to demand these sorts of solutions, and of course, the opposite is also true. That's where codes and standards come in. You could also just say this is the way we're going to build these things in the future. Both are important. Probably need some of each, is what I would characterize. You've been patient. Thank you.
Zach Snyder, Real Estate Board in New York. I think one of the other features of this conversation that hasn't really come up at all is the question of reliability.
Is your green light on?
It is.
Right, great. Perfect. Thank you.
The question of reliability of electricity. I think as you talk to building owners, particularly larger developers and owners, it's great to hope that they electrify, but if we haven't answered the question of what is the relative dirtiness or cleanliness of the grid and what is the reliability of that power, I think you're going to have much slower uptake in the outcomes that regulators and policymakers want to see happen. So I think getting at the question not just of what does it cost and what is the technical challenge, but also on the supply side, what is it, where is it coming from, how reliable is it, and are we assured that it's going to work in a world where everyone is, conceptually 100% electric, which is, I think many people have articulated as being the goal they're seeking. That puts a lot of eggs in one basket and provides very little redundancy and raises real reliability questions, particularly as you move into winter peak and thinking about the ability of people to live in buildings in the winter when there's no power.
Let me have you stay there just for 1 second so I can clarify this a bit. You're in a great position to help us understand this. So when you talk about those challenges, what does it take to get to the tipping point of where there's enough certainty for development to then happen in a different way? Is it an assessment with targeted goals? Is it that things are in a capital plan approved by the PSC? I mean, how far down that continuum? It's one thing to go assess it and say we can be at X by Y date. That's a research project. And then the other end of the continuum is it's got to be in a capital program for NYPA or in the NYSERDA plan or what have you. So what's it take to get to enough certainty from your perspective?
I think every owner would answer that question.
I agree with that.
I think one macro point is I think there's a very open question between city and state policymakers today of what is a compliant building. So if you look down the line to 2050, or 2030 or 2040, or frankly 2025, when there's a very big stick coming to building owners in New York City, what does it mean to be compliant? The city has said it has something to do with the carbon emissions from a building. The state has not said whether it agrees with that or whether it thinks it should be an electric building, a highly efficient building. I think you have to answer that question as a first order of business. I think another key thing to think through is, and I think the state is sort of starting to do this process through the CLCPA, but what is it going to take from a generation side, from a transmission side, from a storage side, from an efficiency side, in a world where we are rapidly electrifying buildings, transportation, and the rest of the economy? And how do what are the real numbers behind that? What do they look like? What is the real plan on paper to deal with that? And I think that starting to see those things, which for very good reasons haven't really existed yet. The state and city laws are 6-7 months old at this point. Will be very helpful to owners to give them some confidence that they're not electrifying their buildings for something that can't supply reliable, clean source of power.
So also we've got to figure out through research or whatever it takes how to increase those confidence intervals if we want to see different action. And
I think you have to start there, but then you also have to then align policy.
Exactly.
Carrots and sticks, whatever they are, to get to that goal. It's not clear that we've done that yet, and there seem to be processes in place to do that, but they need to get to those outcomes.
Thanks for letting me poke at you a little bit with that. Albany, anybody in Albany?
Oh, I think we're good in Albany.
Hey, can you pull back up? Oh, go ahead, yeah, right here.
This is Eli Hammer from NYSERDA. I just wanted to ask about maybe if you could expand a little bit on one of the points that you made earlier. You were talking about the danger of over signaling, and you also gave two examples of the timescales that we're concerned with, which we do care about both. We want flexible, command responsive systems that hopefully would be automated eventually. And we want a price signal that goes with those. But we also have this long-term objective of having this shift occur, which we want a signal that, like you said, might be on the year or even longer time scale. So in what way would you suggest that we should avoid over-signaling, and in what ways should we actually be expanding the different time scales that we want?
Well, just let me give you sort of an example of the differences. And I'll assume sort of a standard technology house which has, we'll kind of make it worst case. We'll assume it's got fossil fuel heating, it's got window rattler, air conditioners, and for the traditional house, and then it's got a geothermal heating system for the sort of the house of the future, the beneficial electrification house. If you can, so that traditional house, you probably want to be reminding them very frequently, say during the summer when it's outside, you probably want to very frequently give them a signal that you really should turn that air conditioner down, because we're trying to get you to reduce both demand and consumption at that time. We're trying to meet a peak demand. So you want to be able to signal them and get them, really drill that message into them. It would be smart. You could save money if you back that sucker off. But now, think about the geothermal house. The mere fact that they put geothermal in there means that they're going to be cooling at dramatically more efficiently than they were if they had any air couple technology, whatever it might be. The geothermal system, unless it's stupidly installed, will be massively more efficient than the air coupled system. Essentially, that one decision of getting those people to move from an air coupled system to a water or ground coupled system, you've accomplished most of what you want to do right there, okay? Now, and you've also got this other benefit in that you've eliminated the fossil fuel, you've increased utilization on your grid, so you're going to be reducing people's electric prices, at least on the delivery side, because you're selling more electricity, you're spreading the cost over greater cost basis, et cetera. That house that installed the geothermal, you really don't want to bug them too much about the kWh consumption, the supply side, because the mere fact that they did it has got you most of the benefits you want there. What you want to do on that house is you want to focus on demand, on the kW issues. So for that sort of new technology, beneficial electrification house, what you want to be doing with them is you want to signal them about things that will sort of encourage them to change the way they manage the use of electricity within the house. For instance, you want them not so much to use less electricity, but you want them to time its use better. Things like the example I like to give is you want them to use technology so that if somebody, say, turns on a hairdryer and suddenly increases their demand by 1.5 kW, you probably want the car charger and the heat pump and maybe some other appliances in the house to know about that and to know, we got a 1.5 sort of spike in demand here. It's probably the hairdryer from one of the people upstairs in the bathroom. Give it 5 minutes. I'll back off for 5 minutes, reduce peak, and maybe we'll come back later after a while. Similarly, you want to do things like, after dinner, make sure that the dishwasher and the shower are not running at the same time because you're going to totally spike your electric water heat, okay? Or, encourage them instead of having distinct water heaters, get them to get the technology so that they're producing, during the summer, essentially getting lots of hot water for free by using a de-superheater or by somehow connecting to their heat pumps so that the heat that they're pulling out of the house, they're putting it into the hot water tank instead of just throwing it to the neighborhood or dumping it in the ground. So you've got a different set of signals that you want to give that are the important signals to give to this beneficial electrification home than the signals that you want to give to the traditional technology home. And also, the kinds of things that you want to signal the higher tech home about are adoption of algorithms or adoption of particular kinds of equipment, or adoption of practices which are infrequent decisions, as opposed to in a low-tech house where they just have draw. What you want to do is you want to convince them right now, turn the light off, right now, turn the thing down. And you're trying to convince the human to be managing the system, where what we really ought to be doing is in the future technology homes, the beneficial electrification homes, we want them to adopt devices, algorithms, et cetera, which are much less frequent decisions. You see the distinction there? So that's why you want to be not only bifurcate these guys in terms of the rates that you charge, okay, but also when you think about things like signaling strategies, you want those strategies to be compatible with the technology base or with the sort of behavioral pattern base that you're working with, and understand that they're distinct. There are at least two different sort of technology, behavioral, attitudinal collections here. They need different kinds of signals with different frequencies. I hope that makes sense.
Great. And were you looking to hop in right before? You were, as I recall.
Just kind of going back to Zach's comment about reliability and signal, not to go back to my presentation, but I think, what's been successful here is you've elevated the consciousness of general public about carbon and understanding, what it means and where the energy is coming from. But I think, that being said, we need a number to follow. So, the goals have been published. We're not sure how those goals are going to be measured. We're not sure, where we are to look to see indicators of progress. And so, I could say ditto, but to reinforce the point, point the public to, a number that measures existing conditions and talk about what that number should look like in the future as indicative of the goal's progress. And then the other piece about reliability, I think we need a lot more transparency around when the grid fails us or is compromised, why it happens, what's being done to prevent that from happening again. So we had a blackout this July in major portions of Manhattan that was sort of unprovoked. You know, it was on a Saturday at night. You know, we were fortunate as a commercial owner that the buildings, you know, weren't occupied at the time. But that really doesn't indicate, you know, how demand played an impact into that and what sort of reliability planning was done in response to that. So I think public perception of reliability is key, as Zach said, and a little more transparency around the repairs needed to prevent that from occurring.
Great, thanks. Bill Nowak online, unmute yourself and join in. Are you with us, Bill?
Can you hear me?
I can now, thank you.
Okay. I just wanted to pick up on the point that was just made about measuring existing conditions and also hearkening back to where Greg Hale started with us with the report that's going to be released in March. I just wanted to caution on the importance of the CLCPA and the way the CLCPA defines greenhouse gas emissions. At this point, methane emissions are a very significant part of what is happening in terms of climate change, and the importance of methane emissions over a 20-year term are really important relative to the goals that we have for the CLCPA, which are basically stated in terms of 2030 and 2050. So the CLCPA, the definitions for greenhouse gas and global warming potential includes both changing the term from 100 years to 20 years and also including the leakage that happens all the way along the supply chain for fossil fuels. And this is really going to change the kind of numbers we use both in terms of baselines and counterfactuals. It particularly impacts natural gas and the way natural gas impacts are measured, but it will also be the case for oil and even the electricity that is produced from fossil fuel plants. So I don't necessarily expect the report's going to have an entirely new set of numbers based on those, but I would think it would be important for the report to take into account the difference that those definitions are going to make.
Great, thank you. And we captured that.
Thank you.
Thank you.
This is Bill Axel from Con Edison. I just wanted to step back and comment on a couple of those things that were said earlier. One was I just want to throw out some caution about technology-specific rates and technology-specific rate classes. Because I think if rate structures are properly designed, they provide the right price signals, regardless of whether someone is using a geothermal heat pump or using some other form of equipment. And the other thing is that as time goes on, there's going to be more and more different types of equipment used in households. So it becomes really just a never-ending matrix of rates if you try and design rates for various end-use technologies. So I think you need to get the proper cost-based rate structure in place, and it will provide the right price signals regardless of the technology behind the meter. Just also the reverse cost shift that Bob had mentioned. That's something that's sort of a blunt instrument or a one-size-fits-all amount that has been proposed in some proceedings to compensate geothermal heat pump customers for this perceived inverse cost shift. So once again, I think a properly designed rate takes care of that problem. And in the most recent Con Edison electric rate case, in the joint proposal that's currently pending before the commission, we do have an optional demand-based rate that I think addresses the geothermal heat pumps as well as other customers that may want to take advantage of it. And just a word about pilots also and flexibility is that we have had pilots that resulted from stakeholder engagement, you know, with a variety of stakeholders with different interests, and come up with in our case, an innovative pricing pilot that's currently underway to test a variety of man-based rate structures. And we also have in development a smart home rate that will not only look at rate structure, but communications of prices to technology. So there are things going on there that do result from, what are sometimes contentious proceedings, but that's sort of what you have when you have a room full of people with varying interests.
Thanks. I guess the one other thing. Grab the mic, please. Thank you. So bad, National Grid, and not taking one step back, not even looking past basically what they did. I think everything Bill said, especially the concern about tech-based energy rates. But when I think I'm now blanking on the name, Calmac, excuse me, talked about a little bit about the incentives around mixing and making choices between technologies and between heating solutions, and we heard a little bit about this about relationship between carbon intensity and electricity usage at any given moment, and there is a rattle proposal for carbon pricing at the NYSO, and obviously you start to do more economy-wide things and you start to get better messages across technologies. So I do want to acknowledge again that there is an active proposal at the NYSO. How active is up for debate, but there is an active proposal at the NYSO about taking steps to harmonize pricing. So that's something that it's not just buildings alone, it's part of a broader energy system.
Great. So a word of caution about unintended consequences of having every technology have its own rate class there, and a word instead for trying to find some simple, elegant rate mechanisms that blend all those together. And then just a reminder to us all that some pilots have been able to be built into rate structures and are moving forward and found commonality. So that's helpful. Are you just going to respond to them, or is it, let me try to make sure we have other voices in the room first. I'll come back to it if we have time. I'm not trying to respond to you. Anyone here? How about Albany? I haven't checked in Albany in a while.
Well, some of it based on everything that's been said today, I think the most logical approach for us all to really be considering would be for every metered electric point to have a sized energy storage system to flatten individual peaks and possibly be drawn upon by the grid in times of need, especially considering that battery prices are soon going to be on par to that of a typical home appliance, individual appliance, not even the collective appliances as they are currently. Because we are, I mean, it's all this talk of all the things of how to regulate the hair dryers and the showers and dishwasher, but I mean, that's a lot of individual control within the home use. And then as you get to a larger multifamily house, that becomes even more complex. So the importance for, basically each metered source being its own little sort of microgrid with that battery, not to supply that building per se, but to be able to make sure that the individual demand from that building never is at its largest peak ability. It's a minor load that's sustainable. And that going future, and also to provide grid stability by having little point sources that can be drawn upon, as is being explored currently in California. That's all. I mean, I'm just saying everything I see being said in that list that we see there.
Great. Thank you. So what I'm hearing there is almost the notion of energy storage being ubiquitous, being required, could be required as a standard, perhaps, and for some other regulatory process. Whether it's instead of the other demand response stuff or in partnership with,
Yeah, similar to like everybody needs a refrigerator. They're going to need to have a battery, basically, something like that.
Yep. Great. Thank you.
Anyone else?
Anyone else? Okay, Dan, go ahead.
Representing the building owner in the room, I'd be remiss to not bring up incentives, how folks are going to pay for all this. And I think certainly in the absence of market signals that we think will be part of the future, I think if we need to make the economics more appealing for some of these infrastructure changes within the building, encourage PSC to continue funding NYSERDA backed incentive programs. There are many good ones out there right now. I think that the industry needs some confidence that they'll be around for many years, so that, as this sort of experimentative technology gets deployed, you can enable building owners to have a multi-year planning approach to this. And so that absolutely needs to be part of the policy that accompanies all this.
Great. So the role of incentives moving forward, and I'm going to go to a caller here in a second, but I would even widen that just by way of having you think beyond is what type of beyond incentives, in addition to incentives, demand response programs, incentives, what would motivate building owners to participate is another way to think about this from a slightly larger wrapper that you could all be pondering. But I think we have Matt Golden on the phone. So Matt, hop into the conversation.
Hi, thank you very much. Can everybody hear me okay?
Sure can.
Excellent. Just riffing off of some of the last comments, I wanted to kind of refocus. I think retail rates are required for us to decarbonize, but also thinking in terms of more wholesale-based signals. We're finding actually in California with our storage systems that they're not doing anything to load balance the grid because they lack an economic signal to do so. And things like heat pumps are actually driving 6 a.m. morning winter peaks, which is some of the hardest to clean electrons of the entire year. So just in a general sense, we would advocate looking towards what is now being called demand flexibility. So measuring, and especially as New York brings AMI online, focusing on looking at marginal values and really putting a large amount of focus on marginal hourly carbon and GHG intensity of electrons, and focusing really on incentivizing the outcomes that we want rather than the individual technologies. With that, heat pump in transmission that's going on in New York, that's going to have to be accompanied by wintertime renewables, storage, and a whole lot of energy efficiency, because the avoided cost on every R value addition of insulation in the attic with a heat pump is actually avoiding wintertime renewables and storage. So we just would encourage a more macro holistic approach rather than looking at individual technologies, and think in terms also of aligning the incentives, not just with the end customer, but through the marketplace that are delivering those services, so that we can engage the businesses in New York to deliver virtual power plants and take that complexity and turn it into products customers can actually buy and understand, and actually make delivering decarbonization in the New York market something that makes businesses money and actually drives innovation and private investment as well. So I think there's some good examples of that starting to emerge, but I think we're going to need a variety of price signals and alignment of incentives across all market actors, including building owners, but not forgetting those companies that are actually deploying these solutions.
Great, thanks, Matt. And I presume that this is the Matt Golden with Recurve, right? Just so we know who you're with.
I apologize. I should have introduced myself. That is the Matt Golden.
Amen. All right, I'm going to be looking for somebody else to hop in, but I also want to just throw on the table, and you don't have to respond to the questions that I'm putting out there. I'm just trying to prompt more thinking from you. We haven't talked a lot about rec policy other than in the presentation earlier. It came up, community choice aggregation, the role of what else do we need to know about community solar, on-site solar. We talked a lot about storage, more on that. So those are some other areas that, what do we need to learn more about, align policy around, get regulatory structures in place, design the utilities rates. Any of those are also open and interested to hear from you on. Anybody ready to hop in yet? I'll get you first and then from you.
Zach Sember, Bradley. You asked about rec policy, and I think that's an interesting part of this conversation. We obviously haven't explored it, and it's in some ways a slightly different, I guess, part of the NYSERDA team. but we've been spending quite a bit of time with our members, as Dan alluded to, trying to understand how RECs operate in New York, and frankly, whether a private property owner today could buy a REC in the state of New York that complied with the city law requirements. And I think the short answer is basically no. There's no private REC market in New York today, and there certainly is not a private REC market because the NIGAT system won't tell you where that energy enters the grid or is consumed associated with that REC. So I think that would be very helpful to spend some time thinking about how do you actually build a private REC market in projects, particularly where you've got this fundamental mismatch, as I understand it, between renewable developers are seeking 15, 20-year permanent, very long-term agreements, and building owners are not generally willing to enter into those very long-term contracts. How do we, sort of figure out how to build a market where the city, where sort of the private sector, public sector, and renewable developers are all aligned to sort of get to the same outcome we want, which I think is generally more generation. So I think figuring that piece of it out is very important, and a lot of very hard thinking needs to go into how to do that.
Thanks. So really getting some thinking around the efficacy of a private REC market, and if so, how you design that and what the moving parts are, so you can get the long-term investment and meet the utilities needs as well. Bob, you wanted to come in?
Yeah, I just comment on things people said before. I'd like to kind of, I totally agree. We shouldn't have technology-specific rates, but we do. We have many of them. We have electric vehicle rates. We have storage rates. We have rates for people who generate electricity as opposed to people who consume electricity. There's a tremendous number of very specific technology-specific rates in the system at the moment. What I was trying to point out before when I said that we should be bifurcating the rate classes is understanding that as people adopt particular technologies and as they take on the behaviors, what they end up with is load patterns, load profiles, which are completely distinct from the average or normal load patterns that exist for the classes as we have them defined today. And those load patterns are ones which, frankly, we find desirable and wish to encourage. It may be that it's the adoption of technology that gets you into the kind of load patterns and load profiles that we want in the future, but nonetheless, the people who are producing or whose consumption has the patterns which are different from existing patterns, but yet are patterns we wish to encourage, I think those people should have rates which reflect their particular styles and patterns of use. And we should ignore the fact that it's driven by technology. It's similar to, we give different rates to people who generate electricity rather than people who consume it. Even though we know that there is value both to consumption and production. For instance, the consumption of a kilowatt of electricity in order to drive a heat pump reduces carbon emissions by some amount. Similarly, the production of a kilowatt reduces carbon emissions by some amount. You get reductions both by consumption and by production here, yet we distinguish between the two, and we give specific rates to people who have positive, sort of emit as opposed to those who consume. So it's not technology specific I'm talking about, but rather understanding that the rate class is not homogeneous, and we should have rates that reflect that lack of homogeneity. Also, on the comment of batteries, if I could just say that, giving everybody batteries would certainly be effective. The question is, it probably wouldn't be terribly cost effective. That stuff's expensive right now. And we should recognize that we have a lot of opportunities now for getting much of that peak saving, the desirable peak saving, by doing things like timing when we consume electricity, not necessarily reducing it, but simply timing it. It's things like having the large consumers of electricity in the home, the things like the car chargers, the heat pumps, the various large electrical appliances having them know about things like the hair dryer turning on, or having, allowing the car charger and the heat pump to negotiate which one of us is going to get power. I need it in about 15 minutes. Would you back off? Give me some headroom here on KW. This stuff may be very complex in the way it works, because you may have dishwashers fighting with heat pumps, arguing with car chargers, who are then having this debate with the clothes dryer. Okay, but it's all a couple lines of software. You can do all this in the background if you do it properly. So we should recognize that, yes, batteries are wonderful things, but we have these alternatives which are managing when we create the loads and managing the simultaneity of loads. If I could just say one final thing, and that is on NYSO carbon pricing. NYSO's been doing some wonderful work on carbon pricing. I really hope it goes absolutely nowhere, okay? And the reason for this is the carbon pricing that everybody says it's intuitively obvious. All the economists tell you that the way you solve this problem is by having carbon taxes, carbon price, and the rest. And they're right, but the thing that they miss is that when economists tell you that, they're talking about doing that on a cross-economy basis on all of the sources of carbon emissions. What is being talked about at NYSO is carbon charging, the carbon tax, only for electricity. And unfortunately, that means that will increase the cost of electricity relative to the fossil fuel alternatives. Okay, which means, yes, it will. Okay, and all the NYSO studies, they acknowledge it, just an argument over how much it is, but it will increase the cost of electricity relative to the fossil fuel alternatives, unless we also have carbon charging in those markets. The markets for oil, the markets for coal, which is still being used, by the way, by thousands of homes in New York State for heating, the markets for gas. So what we need to understand is that when you increase the price of electricity relative to the fossil fuel alternatives, what you're doing is you're discouraging beneficial electrification, and that is not necessarily a desirable thing to do. We should prefer, there's a lot of benefit to the carbon tax ideas, as long as you handle the problem with low and moderate income people. But also, we should understand that single sector carbon pricing, particularly when it's electricity, is a very different prospect than cross-sector, multi-sector carbon pricing. I personally would recommend that in lieu of doing carbon pricing for electricity, or maybe in addition to it, what we ought to be doing is we ought to be removing the implied and the actual subsidies for the fossil fuels. The things like allowing the gas systems to push their costs out to the future and thus undercharge consumers today. If we had more equitable recovery of costs, that would be effectively the same as having a carbon tax in terms of the market response, because it would increase the price of gas. Similarly, we have a lot of subsidies, either in, not in terms necessarily of money, but at least in terms of policy and the rest, that allow the oil, those who sell oil and heating oil, et cetera, to sell at, to not reflect the full externalities of their product. If we were to have them responsible for more of their costs, it would give us the headroom we need so that we can do the really smart things that NYSO was talking about within the electric sectors. But working just in the electric sector on its own essentially shoots us in the foot by discouraging benefits for electrification, and that would be a real shame.
Before we have a debate, let me try to characterize it this way so we won't have to have a debate. I take from all that, we got to avoid the law of unintended consequences. We got to make sure the facts about how we price carbon and what sector and how the facts have to be understood, put on the table, socialized, and then decisions about where we're trying to move to and how to align those policies need to come together in some way. And hopefully, Toby, you'll allow me not to create a debate, because I'm not here for a debate. I'm here to try to get stuff out of people's brains. So thank you. That's not to be argumentative or disagreeing with you. I just wanted to make sure that we kept moving forward.
Scott, I was gonna try to actually move the conversation back, I think, to the original questions you asked.
Great. So Toby and then Rebecca, and we might have time for one or two more after that.
So I had a question, I think, for both you and the building guys, the name I didn't catch at the beginning, about the participation, I think, in participation in rent markets. And I think, Mike, I heard you at a summary say a private rent market, and what I think Isaac was really asking for was, Zach, was a piece of harmonization where city buildings can make sure that they erect a purchases compliance. So I guess the question would be both. It wasn't an ask for a different rent market, it was an ask to make sure that the policies work together. I thought it was both, but I don't want to, I was sort of curious, because about what exactly that was for.
I think it's both. I mean, if I understand your question, I mean, I think that there are sort of two pieces to disentangle, as I understand the world today. One is that there are, under the city local law 97 framework, there are effectively no recs today that would comply. There's also a separate issue of how a building owner, tenant, private actor buys recs in the state of Florida. And that's a different question. When you layer the two together, it gets quite complicated, I guess.
Thanks. But I think I did want to go back to where you started about the questions around, I think you're looking for guidance in the roadmap about the role of community generation and CCAs.
Yep.
So in New York for community generation, you're working on monetary crediting. So your buildings still, and so the resource generates credits that are worth a certain amount and allocates them to subscribers. The building itself will still have an underlying charge for delivery and supply. So the community gen credits could be applied to either if they're getting full service load, but it's not a solution to either rates or technologies that need to be in the building. So I actually don't think I don't think that's necessarily a big part of the roadmap, although I don't be open to the suggestion I'm 100% wrong, but that strikes me as a pretty distinct set of solutions and issues because of the way New York has set that up to its credit. CCAs, I think, raised the issue that we spoke a little bit about this morning, about being clear about whether we're talking about delivery and network costs or supply costs. CCAs aggregate over supply costs. And there are, whether the state itself puts regulatory requirements on CCAs to do certain things or not, that's on them. But it's really comes back again and again to delivery versus supply, and so what the levers are and what your ask is of the CCA and where the customer takes it is in the building supply.
Great. Thank you. On to the mic, please.
Hey, Chris with Sunrun. I'm going to take it a little bit of a different direction. Just in terms of thinking about not having technology-specific rates, we also need to think about not having technology-specific metering, but rather thinking of buildings, especially residences, as a whole home asset, and what service is it providing. So is it demand response or is it clean energy that was either generated in real time or stored? And we've seen in other markets metering really hold us up by sometimes even a year, maybe longer. And there's been really interesting things on the horizon, whether it's Green Mountain Power using a Tesla Powerwall to eliminate the utility meter altogether, or there are companies now that are integrating revenue-grade metering directly into the home's electrical panel that can track all of the circuits. So as we think about a building as a resource, we should be thinking about metering standards. So revenue-grade metering with a certain amount of accuracy rather than technology-specific metering.
And in a way, what I hear you talking about is almost a move from where we are today with some complex technology specific to really the grid interactive building rate, right? If you really meet a test, be considered a gem, then you can really move in the direction you're talking about. Yeah. Anyone else? Okay, I think what we're going to do, I ran a little bit over because you all had such great input on this piece, and frankly, it was a wide-ranging and really helpful from my perspective. Hopefully the NYSERDA folks think we got what we were needing out of this. There's a lot of input here for us to consider on this side of the conversation, a lot on utility rate design, a lot on some of a whole slew and series of cautionary tales about unintended consequences and making sure we get what we actually want instead of thinking we're getting it and creating different problems. That really gets to the need to, that's really why this roadmap is being built, is to try to think through and piece together. You can never totally get rid of unintended consequences, but road mapping is kind of fundamentally trying to take that holistic view and pull it together. So I think I'm going to, I think Greg is going to close this section. Just remind you that at 1 o'clock the next one starts. But Greg, I'll kick it back over to you.
Thanks, Scott. Ditto. Great input this morning. If you have more input, we're always open to it. So you can either reach out directly to me or one of my colleagues here, Zach, Caitlin, Pooja, or send emails to the Carbon Neutral Buildings Roadmap web address that is right on the screen today, right now. So we're going to take a short break and then come back and start talking a little more about the technological aspects of this building grid integration and what we need to accomplish to make this technically feasible to then work with the great design that we've talked about today. So thanks everybody, and talk to you again soon.